Hello, everyone. We are back. Thank you for staying with us. Right now, we are starting, as Kelly previously said, that we are going to start vlog number 4. So I just want to share with you that we are now having like these 12 hours of live transmission. So we are like just in the middle of this beautiful event. So right now, we are going to start this vlog. We're having different guests, but we are going to start with one of our pre-recorded videos.
Starry sky. The starry sky. Fascinating and mysterious. 100 years ago, an invention that brought the sky down to earth. Inspired by the founder of the Deutsches Museum in Munich, Oskar von Miller. Developed by Walter Bauersfeld, ingenious designer at Zeiss. The first artificial stars were lit in 1923, and since 1925 were shown in the first planetarium. Today, there are more than 4,000 planetariums all over the world. The starry sky was just the beginning. Today, the projections lead us deep into space. Planetariums are our gateway to the entire universe. Planetariums tell the story of our Earth, our solar system, and our whole cosmos. They explain the night sky, awaken curiosity about the unknown, expand horizons, and inspire us for our own lives. They address the biggest questions: where we come from and who we are. Planetariums promote the understanding of global connections and excite visitors for science and technology. Planetariums offer diversity. They combine science and art, culture and education under one roof. Our knowledge of the world keeps evolving, and with it, the planetariums that present it. They have done so for 100 years and will continue to evolve in the future. What secrets do we explore next?
Hey, welcome back. Such an amazing video, very, very inspiring also. Great to see all the different activities that we can do in a planetarium. The video with the art and the music was awesome. So that is giving me a lot of ideas to implement here in Mexico. So right now, I'm happy to welcome our next guest, who is Shannon Small, President of the International Planetarium Society and Director of the Abrams Planetarium. Thank you, Shannon, for being with us in this amazing celebration.
Thank you so much for having me. I'm so excited to be here and to see like all the activity that's been going on for the past 12 hours. So
Yeah,
this is amazing.
it has been amazing. So please, I gave you the microphone so you can tell us about um, your work and what about you're going to share.
Yes, thank you so much. So I think that video did a wonderful job of kind of showcasing what planetariums are able to do. And I kind of want to talk a little bit more about what that video is sharing about why I think planetariums are such an important tool and why they're such a powerful tool. And um, I see some. Okay, good. The internet's back. Okay, but why they're such powerful tools, and why I love them. So I do have some slides. I'm going to. Oh, if I can share, that would be lovely. And then I'll be able to. I'll have some slides. If I can't use them, that's okay. I can always wax poetic about planetariums because I do love them so much. There we go. I will share and present. Okay. All right. Hopefully that is full screen for everyone. But the planetariums started as a way to teach astronomy. That was something that Oscar von Miller wanted, was a way that we could actually recreate the night sky so people could see how it's projected, how it changes, and interact with it in a way that we couldn't do in an everyday way. And I think that then takes us back to why is astronomy so fascinating to people, and why is it so important. And so it's often called a gateway science. It's a really great way to get people interested and start their curiosity in sciences and math and engineering and technology and art. And so this is a quote from Dr. Will Armentrout from the Green Bank Observatory that astronomy is a gateway science. It's so accessible, you can just look up at the sky and wonder. It might be the first thing that gets someone interested in science. Even if they don't become an astronomer, they might pursue that curiosity, become an engineer or a physicist or a biologist. And there's so much it can introduce you to. And I think at the heart of that, it is we all, as we keep saying, and we always say, is we all share the sky. It doesn't matter where you live in the world, we all can access that same sky in a way that maybe like we don't all have the same flowers and we don't all have all the same animals or all the same birds. But and the same environment around us and climate, but we all can go outside and see that sky. So I think that is a really important starting point. And this is a picture of the Southern Cross from Chile from when I was there in June. And that's me pointing out the Southern Cross to my daughter just outside of a restaurant in the middle of a city with light pollution, just to kind of emphasize just how accessible astronomy can be in that way. But I think it's more than that. I said this like 12 hours ago, so I'll say it again for anyone else. But astronomy is something that connects to so many aspects of humanity and the human experience. Like it is a science, and we are making wonderful, amazing discoveries about black holes and how the universe is expanding, and we're creating amazing technologies in order to be able to do that. But humans have been looking to the sky and using it throughout the existence of humans. We've been using it to tell time. We've been using it to navigate. We've been using it to tell us when it's time to move camps or when it's time to harvest certain things. We use it for storytelling to share important values related within a culture or to share important observations. We've used it to build specific structures in order to align with different phenomena in the sky. We've used it to develop technologies, and it also inspires us in so many different ways as well. So it inspires our storytelling and our fiction and our movies and our books and our TV shows. On there, there's a picture of me sort of on the bottom row wearing a dress with space and planetariums on it. I'm actually wearing it right now. Or like Star Trek. I love Star Trek, so I have to give a shout out to Captain Janeway. But it is something that seems to permeate so many different aspects of our life. But for how accessible astronomy is, it's rather intangible. We can't go outside and just touch a star, or we can kind of touch meteorites. Like that's something tangible, but for the most part, we can't touch the sky. We can't touch the stars. We can't just pop out to Jupiter and see what's going on up close. It's millions of dollars to make a robot that can fly out there over many years in order for us to get closer images. And so it is something that's hard for us to see. It's happening over really long time scales. We can observe things like the sun moving across the sky, but or the moon, don't look right at the sun, never look at the sun. But if you're looking at the moon, it's hard to notice how it's moving in the moment, but over an hour you might see that change. And so that sort of immediate pattern recognition is a bit harder. And so that's where I think planetariums, why planetariums are so important, is because they are able to recreate that experience, but then add something on that helps us notice those patterns to help us understand those things in different ways. So we can outline constellations, we can put up angular measurements, and it can make us feel like we are in that sky again. And so we can go to any date or time or place and speed time up. It is an immersive experience, so we get to feel that experience of being under the night sky. The oohs and ahs that I get every time I turn on the stars in my planetarium is always palpable. Like it's something you just feel in there. And I think unlike other immersive experiences like virtual reality is really, really great, but it is a very personalized experience. And in the planetarium, it is something that you can share, much like you can share the experience of the real sky as well. And so I think that's part of the power of planetariums. And so what that means when it comes to learning and connecting and identifying patterns within the sky is it helps us with our spatial reasoning. When we have something that's happening in 3 dimensions around us, being able to recreate it in those 3 dimensions helps us understand the angles or how moving to different parts of the world changes our perspective. And you also have that time element where you can speed things up. So being able to actually have things in context is really important. And that's useful not only in astronomy and understanding the sky, but I've used this for teaching about art and being able to project, or architecture, being able to project a room around you to see where things sit in context is a really powerful experience. And it helps us shift the perspective. So with modern planetariums, we are able to fly off the Earth. We're able to see the solar system, and we're able to do that in one smooth motion so that we are able to see how these different perspectives and locations are related to one another. And I think it's also the closest we can get to feeling like we are in something like Star Trek or Star Wars, where we're just going to pop out to Jupiter. We can do that in a planetarium. And that's a really exciting feeling to be able to get to do that. And again, because you're in there with other people, we can keep it really interactive and we can adapt to our different audiences according to what you're interested in. And we can individualize that so that we can connect with people on all of those different ways that astronomy touches on our experiences through the constellations, through storytelling, through scientific questions, and so on. So I think it allows for a much more active participation by being a big room that we get to experience it all together. And it does inspire us in a lot of the same ways that the real sky does. There has been a lot of research on this. That feeling of awe and wonder is shown and felt in the planetarium like it is outside with the real sky. It also makes us wonder. It makes us excited. It makes us nervous. Sometimes it makes us sleepy. It is really cozy in there and dark. So I don't get offended if people fall asleep. But it does help us feel those feelings that are also part of that curiosity and wonder. And with that new technology, we are able to explore so many different things as well that aren't only astronomy, but have those connections to astronomy, or even not the immediate sense. Like we can explore bugs and we can look at trees and we can look at environments and medicine. Like these are all topics I have taught at the university that I work at in the planetarium there. We've had performances and drama there. And for me, like that's all included because it's all part of the universe. It's all part of the cosmos. And that's what we do is we learn about the universe in planetariums. So everything that we know about should be fair game in there. And I think that's what really makes them so powerful and so exciting. And it's why I love planetariums. So I think that's my time. So thank you so much.
Thank you, Shannon. That was an amazing talk. I share with you all this excitement about planetariums because one of the best experiences that we can have, like knowing the universe, is in a planetarium. So it's really amazing. A beautiful talk. Thank you so much for sharing this passion with us and being here in this celebration. Thank you, Shannon, a lot.
Thanks for having me, and I'll see y'all later.
See you, Shannon. Thank you. Okay, so right now we are going to have another talk. Welcome, Dominic.
Thank you.
Thank you so much for being here. So please introduce yourself and please let us know about what are you going to share with us.
Perfect. So I'm Dominic Virtue. I'll be sharing about the astronomy for mental health that we're working on at the Office of Astronomy for Development. I feel like Shannon almost did a very good introduction already for what I'm going to be talking about as well. So let me see if my slide is sliding. Yes, there it goes. So good morning, good afternoon, evening, everyone. Like I said, I'm Dominic Virtue, and I am passionate about advocating for something that might not immediately connect. And that is the vast, silent expanse of the cosmos and the intricate, often tumultuous landscape of the human mind. For centuries, humanity has looked up at the stars, seeking answers, comfort, perspective. We've mapped constellations, navigated oceans, and dreamt of other worlds. But what if the greatest journey that the stars can inspire isn't outwards, but inwards? What if astronomy holds a key to unlocking greater mental well-being? So today I'll talk to you a little bit about the work that we're doing at the International Astronomical Union Office of Astronomy for Development, Astronomy for Mental Health project. Now I know that's a mouthful, but the concept is quite simple. We are exploring how engaging with the universe can serve as a unique, accessible, and impactful tool for nurturing mental health, fostering resilience, and finding sense of belonging in an increasingly complex world. Now, let's be honest. Mental health is a global challenge. Depression, anxiety, isolation, these are not just buzzwords, but they're the reality that millions of people live in every day. Traditional interventions are absolutely vital. But what if we could offer something to complement these? Something that taps into our innate human curiosity and wonder. And that is where astronomy comes in. Imagine the feeling. You're under a truly dark sky. The Milky Way stretches above you like a spilled canvas of diamonds. You point a telescope, and suddenly Jupiter's stripes appear, Saturn's rings, or the ethereal glow of a distant nebula. These are all things that you can experience in person or much more accessibly through planetariums. Now, in that moment, for many, it is a profound shift. The everyday worries, the constant chatter of our minds, the pressure of deadlines, they all recede. You are no longer just you. You are part of something unimaginably larger, older, and more magnificent. And this isn't just poetic license. There's real psychological impact happening. Studies to collaborate this. Firstly, when looking at perspective, our problems, no matter how daunting and overwhelming, by looking at the stars, it's almost like a cosmic reset. Seeing the Earth as a pale blue dot in the vastness of space doesn't diminish our lives, but it helps us to reframe our challenges, put it into a larger context, and remind us of our shared humanity and the fleeting nature of many of these challenges. Mindfulness, when observing the night sky, when looking up at the dome, when experiencing these moments, you are present. You're not dwelling in the past, you're not worrying about the future, but you're engaged in the act of seeing and discovering. And this is a powerful antidote to the constant distraction and mental clutter of modern life. It calms the nervous system and it sharpens our focus. Connection. Astronomy is inherently social, whether at star parties within a planetarium, astronomy club, or just sharing views with a friend. It fosters community, encourages shared wonder, conversation, and a sense of belonging. These are essential in combating loneliness and isolation. And finally, awe. The feeling of awe is a powerful psychological experience. It makes us feel smaller, yet simultaneously more connected. It expands our minds and sense of possibility, and studies have shown that this leads to generosity, humility, and overall well-being. Now, how does astronomy for mental health actually play out in the ground? Working with mental health professionals and community groups, we organize sessions that combine stargazing with reflection and discussion. It isn't just about identifying constellations, but facilitating dialogue about the feelings and insight that arise from these contemplations. We offer workshops teaching basic astronomy, but the focus is on the philosophical and psychological implications. And also understanding the science behind the cosmos can also be just as calming and perspective shifting as observing it. And finally, community building. We support the creation of safe, inclusive spaces where people can gather and share their experiences, connect over a shared love for the universe. And this is particularly vital for those populations that are experiencing social isolation or vulnerable. Now, we've seen incredible early results. People report reduced stress, greater sense of calm, improved connection, and a renewed sense of purpose. It's important that this is not a replacement for therapy. It is a powerful additional tool to include within therapy. And it is an accessible pathway to self-discovery and emotional regulation. Think about it. In a world that often feels fractured and chaotic, the cosmos offers a unifying narrative. It reminds us we're all made of stardust, connected by the same fundamental forces, sharing this tiny, incredible planet together. It is a profound equalizer. So as I end off, our Astronomy for Mental Health project is more about than just looking at pretty lights and objects in the sky. It's about harnessing the fundamental human drive, our curiosity about the universe, and turning it into a resource for inner peace and mental resilience. So my invitation to everyone is simply look up and take a moment, gaze at the sky, the moon, or just the vastness above you. And as you do, consider the support and people around you. Support these type of initiatives which bring this perspective to those around you. because sometimes to truly understand ourselves, we just need to look a little bit further. Thank you. And then I'll let this up for a little bit. We've got our website for anyone that wants to reach out or find out more information, and the email address is also available. Thank you very much.
Awesome. Thank you, Dominic, for this amazing talk, for bringing us such an important issue that we are like, we know that we are in different problems around the world, and we need to find some safe spaces to be with, and the planetariums are a great space for this. Thank you so much for bringing us that perspective. We'll be sharing all the link on the YouTube channel so we can check it more, but thank you so much for this amazing perspective.
Thank you. See everyone around.
Great. We will be continuing with more talks live in this great event celebrating our 100 hours of astronomy and celebrating also the planetariums. As we can see the talk with Dominic, it was very inspiring and also a great opportunity also to be to visit a planetarium near you, just like to improve our mental health. So right now we're moving to our next speaker. It's Pekka. So please join us to this conversation and to share all these amazing experiences that we are having. So welcome, Pekka. Okay, let's have some minutes so Pekka can join us. Okay, yes, here we go.
Hello, can you hear me?
Yes, hello.
Hello.
Welcome.
Thank you. We're not live yet, are we?
Yeah, I think that I can see you. Yes, we're live, Pekka. Yes. Yeah, we are live and on YouTube, so you are welcome. Yeah. Okay, great. Awesome.
Okay, yes.
Okay. You can go ahead.
Okay, thank you.
Yes, thank you, Pekka, so much for being here.
Yeah, sorry, but we expected to start at 6:35, so I'm kind of starting a little bit from the middle of that. But let's still start. Okay, I will hand over the camera to my camera assistant. One moment. I try to turn it around like so. There we go. You can see that we are in a planetarium. Can you still hear me okay?
Yes.
Let's see. 1 second. Can't hear you now. Okay, there we go. All right, I hope you can hear us in the live stream. Greetings from Finland. My name is Pekka Rautelki. I'm the Vice President of the Astronomy Club Tampere and Ursa, based in Tampere, Finland. And we are currently located in the planetarium of the amusement park Särkänniemi. Our club was founded in 1950, and it's currently celebrating its 75th anniversary. We have currently over 500 members, and that we heard makes us the biggest regional astronomy club in the Nordic countries. We started our cooperation with the Särkänniemi Planetarium last year, and we host traditional hosted planetarium shows every second Saturday here in the planetarium. The planetarium that you can see over here has 135 seats. It has Digistar 7 and 2 projectors installed. And we usually show the sky at night show every month, how the sky changes, and also our regular programming, which is the stars and the universe show. During the summertime, when Finnish summers are very light, we will replace the Sky Tonight show with the solar system related show. I will now turn over to our club president, Sofia.
I am Sofia Järvinen, the president of the club. Our club, in fact, turns 75 this year, and we have our anniversary party here tonight. And quite by coincidence, during the 24-hour live stream celebrating the 100-year-old planetariums. The main mission of our club is to popularize science in general and astronomy. We feel that planetarium shows are an excellent way of fulfilling our mission and popularizing science under amazing simulated sky, which never suffers from the cloudy Finnish weathers.
And we, of course, in Finland have the main contribution into the popular music in the form of heavy metal music. And it's only proper that our 75th anniversary and also our 5-minute live presentation hosts some heavy metal and a novel niche of heavy metal called astro metal, meaning that the astronomically themed songs are composed by Teemu Villamo and performed by the band Eris Capella. With the sounds of Eris Capella, we wish that all people of the good planet Earth keep looking up. We'll get you some music in a minute. And with these sounds, Finland is signing off, and I guess next we have Mexico, if I believe correctly.
Yes.
So
Final
good night
greetings from
from
Finland.
Finland.
Good night.
Yeah, I think it was such an amazing experience. Thank you so much, Becca. Yes, thank you so much, Becca, for getting us to Finland. I mean, having a heavy metal concert in planetarium from Finland, such an amazing experience. Thank you so much for that. So that's one of the things that we have been seeing in this blog is how the culture is bringing us together in the planetarium.
Exactly. I hope it was okay.
It's beautiful. Thank you so much. Such an amazing
Excellent.
idea.
Thank you very much. All right. Goodbye for now. Bye.
Bye, Pekka. Thank you so much. Awesome. This has been giving me a lot of great ideas to engage with public with different activities. So that will be like pretty amazing. Please let us know in the chat comments. What do you think about having these cultural activities in a planetarium? I think that's a great way to engage with different publics. I hope that we have more time to be in the concert in Finland. I think that they are having a great time. Also, we have different activities in the YouTube chat. So please answer the share your thoughts. We have some questions around. So right now, also we are going to see another pre-recorded video. So thank you for being with us in this
This word Aboriginal, it's not a traditional word. This is once again like a colonial construct. It's a homogenizing word that sort of combines a group of 250 different Aboriginal countries. So these are very diverse, distinct countries with distinct languages, which within 250 different languages has their own dialects and subgroups. So that's around 700 different dialects. So we are a very varied people. And quite often when we're discussed, we're sort of combined into one group. But you should think about Aboriginal Australia much in the way that you would think about any other continent. For example, I give the example of countries like Italy and Germany. These are countries in Europe which are neighbouring countries, and yet we're quite familiar with the fact that their foods, their culture, their language, their history, their people, their land is quite distinct from one another. And yet when we talk about Aboriginal Australia, we tend to use this term Aboriginal Australia and sort of smush us all together. But we're not. We are a very varied, diverse people, and we should be approaching Indigenous knowledges with that understanding and respect for, I guess, country-specific knowledge. Knowledge that we deal with is related to place. When it comes to Aboriginal astronomy, especially for a culture that is the world's longest continuing cultures, so over 60,000, 80,000, 100,000 plus years of continuous culture, all of our information and understanding has been transmitted in an oral format. And so when it comes to science, a way in which we can encode and transmit scientific knowledge for thousands of years, for many generations, and keep that knowledge intact, is to use a number of different memory and information storing techniques. The one that's relevant to me to talk about today is how we can use story to encode science. And quite often this is taking a piece of scientific phenomena that we can observe in the skies and assigning a narrative to it, whether it be talking about a moon man and a sun woman, and the way those two characters interact in the story to describe the way those objects are moving or interacting in the night sky. And so this is a technique that we're very familiar with, even though, often I feel sometimes some people have some apprehension to accepting this form of knowledge transmission. But it's just like any sort of Greek constellation story you may have heard. This is seeing an object or phenomena in the sky, deducing an understanding from what we're observing and the way that it connects with our environment, and then assigning a narrative, a story to it to help us remember it easier, to help us be able to encode it in simpler or more complex formats so that we can convey that information to the appropriate person in our community whether that be a knowledgeable person or simply just a child, we can adjust the complicatedness or at least the depth of knowledge that we are giving across in this story. Also, we have to address this idea of interconnectedness. So when it comes to our knowledge systems, they are so intrinsically interrelated to one another. Whenever I'm talking about sky knowledge, people ask me to speak about astronomy. It can never just be about astronomy, because our skies are constantly telling us about things that we need to understand in our environment. And so our skies essentially start to become like our library. Each star that we can see in the sky will be related to an area of, say, plant or animal knowledge, helping us predict or understand seasonality or weather predictions on a shorter time scale. It helps us encode our histories and our laws and our social values just by making this connection with this star and our observations and what it's telling us, and assigning a story which can convey those moral values. So our skies then become our libraries, because each of these stars are like our books. And so as we hide these skies, we lose access to a very important resource for us, which we have had access to for tens of thousands of years. And this loss of access is happening quite rapidly. And it's something that continues to increase with the fact that we are ever expanding. Cities are getting larger, more populated. We are lighting further out into the country. I know my regional town in Victoria, the skies that we see in the middle of my town now are very different from what I grew up with. And it's something that is getting worse every time I go back home. And so it's important for us to talk about this issue, because it's not just a cultural heritage issue in light pollution increasing and losing our access to the skies, which is super, super important for us, but also it is having a very significant harmful impact on the ecological health of our environment. So a lot of our native species are suffering very catastrophic consequences of light pollution, of artificial light being present in their environment. To give some context of the way that the skies can help inform our understanding of the environment, I'll just briefly touch on the example of the emu in the sky. So the emu in the sky is a dark sky constellation that you actually find in the dark spaces of the Milky Way across the sky. And it's a very important shape, and it is recognized by many Aboriginal countries, as well as being recognized by other Indigenous communities around the world. For my mob, Gomeroi, when we look for the emu in the sky, we recognize it as Gawaragai. And it's telling us a lot about what is happening to the emu on the ground throughout the year, which we know as the Dinawan. And in particular, the one thing that it focuses on the most is this emu egg harvesting cycle, because emu eggs are a very important food resource for us, and the position of the emu in the sky at sunset throughout the year is going to change, and the way that it changed acts as a calendar for us to understand the emu's behavior on the land and when we can be safely harvesting or collecting emu eggs and making sure that there is enough for that population to prosper. This is it's an oral tradition, a story that has so many layers of information encoded within it. So, not going into full detail in this moment here, but it's something that informs us about seasonal change throughout the year, so what conditions we can expect in our climate, our access to water and its availability across the year, as well as helping communicate our social values once again as well, with a firm focus on sustainable harvesting. So we need to be able to see these constellations to be able to understand a lot about our animal and plant cycles. There are so many more examples which I could speak about for hours, but that is not the point of today's chat. And so then when it comes to light pollution, we are seeing an incredible increase in light pollution right across the country, as I've said, extending into rural areas. Light pollution comes in many forms, but ultimately it all sort of comes together in this effect that we call sky glow. So this light that we have all in our environment, which isn't lit with purpose, which is sort of, excessively overlighting business buildings, or, having neighbours' bright lights spill into our yards, or having, street lights which are not properly fitted and are sort of just spilling up. All of this light is also going up into our skies, and so it is impacting our ability to see stars, but it's also very severely and unfortunately super effectively impacting our ability to see faint constellations, features like dark sky constellations, those regions those dark regions that we find in very faint, delicate features like the Milky Way. 80% of the world's population lives in a place where you cannot access these features in the sky, let alone you only see a few hundred stars instead of several thousand. So light pollution is a big problem, but the thing is, it seems like a lot of people just get very used to it in their environment. It gets very much normalized to the point where if you live in a city for long enough, especially if you never venture out into the country often, it feels normal to only see 100 stars in the sky. The reason that it's so concerning for us is not just losing access to our library above, but also for the impact that it's having on a lot of our native species. And there are so many examples I could give about this issue, but I do want to highlight one in particular that has been incredibly shocking for me, which is that of the mountain pygmy possum and the bogon moth. So the mountain pygmy possum is a very cool, very special species in Australia. It is one of Australia's, if not only, hibernating marsupial. It is this gorgeous, tiny little palm-sized possum, which at its maximum is around usually 80 grams. The thing is, it hibernates for 7 months of the year, and in that time it loses half of its body mass, approximately 35 grams when it emerges from its hibernating period. And so the issue is that when the mountain pygmy possum comes out of hibernation, it needs to eat a lot of food to be able to accumulate the mass it needs to be able to go for the rest of its year, and then eventually hopping back into hibernation. Its main food source is the bogon moth. Now, the mountain pygmy possum there's only like 3 sites in Australia that have this species anymore, only 3 populations. And the bogon moth is very sensitive to light cues in its environment. And so it's a migratory species that we rely upon to re-enter the possum's environment at the right times of year for it to feed on. And over the course of, I think, about 2018, the bogon moth's population went down from billions down to just a few hundred. This is a dramatic drop in availability of food for the mountain pygmy possum, and it led to an incredibly horrifying, very high percentage of the mountain pygmy possum's young not surviving infancy. And so this very beautiful, cool, unique species in Australia is now pretty critically endangered and is unfortunately sort of running out of options for survivability. There were campaigns trying to highlight to the local people about the impact of light pollution on the on the bogon moth's migratory pathway, and a campaign was made to try and just stop people from, just turn off your lights to try and see if they could fix this issue. And unfortunately, that campaign was ineffective. At present point in time, there hasn't been an increase in the bogon moth's population size. The mountain pygmy possum, I know that there have been attempts to try and either introduce a new food source, to dramatically change the possum's cycle by forcing it to not go into hibernation and getting it used to warmer temperatures. And so these are very drastic solutions to an issue that could be relatively easily solved, particularly when we look at transdisciplinary methods of collaboration and attacking this issue. Because it's an issue that impacts cultural heritage, as I've said. It impacts astronomers with our ability to access skies and take our observations, and also having this very harmful ecological impact. But it's also an area in which it can also benefit astrotourism and the lighting industry for all of us to come together and to tackle this problem. And so I think this is very worrying, not only for us losing a lot of our very important species, but because this is happening to a lot of animals in Australia. Another example is that of the Tama wallaby, which is another animal which is unfortunately getting misled by lighting cues in its environment and birthing its young into a time of year where there isn't the available food for it to be able to prosper. So a lot of these animals are being harmed. And as I said at the start of this, we have a very interconnected knowledge system. The skies above tell us about animal and plant cycles and so much more that we have been able to develop over the course of tens of thousands of years, this understanding. And so what's happening is we're losing a lot of species, we are losing our access to the skies, and also our interconnected knowledge system, which is so unique and so deadly, unfortunately is also becoming out of sync and harmed by light pollution present in the environment. And so this paper was very important for us to write because everybody deserves access to the skies. And for a lot of cultures around the world, particularly Indigenous cultures, the skies are the backbone of our knowledge systems. And so if we can't see our stars, we can't see our books, we can't access our knowledge.
Hello, everybody. Welcome back. Right now, we are going to have a very special live transmission because, as you know, and we were saying just before, in some places in the world is getting to the morning. So we are going to have a sunrise transmission so we can share it all here. So the sunrise transmission that we're going to see is from Mauna Kea, Hawaii. Okay, as you can see, such an amazing look. One of the things I really love about sunrises is the colors. How are we transitioning from the night sky to a bright sky? But these different colors, the blue, the orange, for me are just amazing. So what we are seeing right now, there are some observatories that are in Hawaii, and is the Subaru telescope. So I think that that's such an amazing view. So you see, so if you are in the YouTube channel and in the chat, please share with us all your thoughts about this amazing sunrise, and tell us what do you love about this moments. Yes, thank you for sharing this. Yes, I can see that you're saying that so beautiful. Yes, I agree with you. So beautiful. I also want to ask you, where are you from? From where are you connecting to? So we can share this live stream. I know that there are people from Mexico, from Peru that are around, because right now in Mexico we are also in the morning. Yes, also sunsets are one of my favorite things. Sometimes we are in a rush in our days, and we don't take the time to appreciate these moments of the day. Yeah, hello from Kosovo, from Romania. Hey, hello, thank you for joining us. Um, Sí, sí, hola, hola también a todos los que nos estamos conectando desde el continente americano. Ahorita estamos disfrutando lo que es un amanecer desde Hawái, uno del telescopio Subaru. Así que esta es una gran forma también de sentirnos conectados y estar disfrutando de eh, lo increíble que es todo nuestro planeta y nuestro cielo. Y lo que les comentaba hace unos momentos cuando empezamos la transmisión es que a una de mis cosas favoritas es precisamente ver los colores del amanecer. Thank you. We are going to continue. That was an amazing view of the sunrise. I hope you really enjoy it. So we're going to continue with the next pre-recorded video, and I hope you enjoy it.
El Planetario de la Universidad de Santiago de Chile fue fundado el 14 de marzo de 1985. En 1969, Alemania dona a Chile el proyector Carl 6 Sexto.
Planetario cumple 40 años ahora en marzo, ¿no es cierto?, del 2025. Es un gran reto estar a cargo de estas celebraciones. Nuestro proyector, el arquitecto Oscar McClure, lo diseñó que se alojara en un ascensor hidráulico. Entonces, cuando proyectamos lo digital, el proyector óptico está abajo. Y finalmente, cuando queremos hablar de las estrellas, del cielo nocturno que se vería en Santiago ese día, sale el proyector óptico y nos muestra el cielo que ya no podemos ver.
Un planetario es fundamental para poder divulgar como la astronomía científica que de repente uno ve muy lejano en los observatorios, a cada persona. A nosotros nos visitan aproximadamente 180.000 personas al año, y esas 180.000 personas al año puede que no hayan tenido alguna oportunidad de ver o estar cerca de la astronomía.
Ha tenido una evolución bastante grande desde el punto de vista del cambio tecnológico, como también de la visión que tiene un planetario. Y no porque este planetario ha cambiado por sí solo, sino que en sí todos los planetarios en el mundo han tenido, gracias a la transformación digital, han tenido un vuelco. Si bien un planetario es un lugar donde se divulga la ciencia, pasó a ser un centro de divulgación de la arte, la ciencia y la tecnología, un centro cultural. Y eso ha obligado a todos los planetarios y nos obligó a nosotros también a poder evolucionar. Y gracias al cambio tecnológico que hubo acá en el planetario, que fue desde el sistema análogo que teníamos con proyección, con diapositivas que eran imágenes fijas, a un cambio tecnológico con proyección digital, con 8 proyectores de video.
De las cosas importantes que se han organizado en el planetario está el Día de la Astronomía cada año, que se celebra en marzo. Por ejemplo, el 2023 hicimos un proyecto donde recorrimos 15 regiones de Chile, desde Arica a Coyhaique.
Pudimos exportar nuestras películas, tener el reconocimiento de marca Chile en nuestras películas. Y eso significó que actualmente nuestras películas están siendo exhibidas en varios planetarios del mundo, en México, en Buenos Aires, en Colombia, convirtiéndose en verdaderas embajadoras de la astronomía en Chile. Los niños, las personas que nos visitan, tienen contacto primero con tecnología de punta, segundo con una experiencia en el domo de 20 metros inmersiva, donde realmente sienten que viajan al interior de una nebulosa, que logran conocer Marte o Júpiter, que pasan por el cinturón de asteroides. Entonces, la verdad, este formato inmersivo nos permite explicar complejos contenidos astronómicos o científicos de manera fácil. Mucha gente ha venido con sus hijos porque hace muchos años vinieron desde la escuela o del colegio y ahora traen a sus hijos. Así que realmente es una experiencia que yo diría que es transversal para los chilenos. Para el 2030, cuando nos van a visitar 3.000 astrónomos de todo el mundo, nosotros tengamos nuestra tecnología renovada a un sistema láser, para que los astrónomos que nos visiten en este marco, ¿no es cierto?, puedan hacer charlas magistrales en nuestro domo en vivo.
Desde hace 40 años, Planetario realiza la producción, exhibición y exportación de películas al extranjero y la exhibición aquí en Chile también de documentales y películas astronómicas para niños. Realiza cursos de astronomía, talleres. Realizamos las charlas de divulgación científica desde hace 18 años, los primeros martes de cada mes, donde científicos, astrónomos y astrónomas chilenas comparten sus conocimientos con niños. La misión de Planetario es acercar la astronomía, la ciencia, la cultura y el arte a los niños, niñas y adolescentes, y hacerlo de una forma entretenida y educativa.
Tu viaje en el planetario comienza aquí.
Such an amazing video. It's incredible to see all the activities that are happening in different places around the world. We're going to continue with our program, and we're also going to see another pre-recorded video, and let's see it.
Oaxaca, tierra de tradición y conocimiento ancestral. Antes de la llegada de los europeos, nuestros antepasados ya miraban al cielo con una sabiduría asombrosa. Las grandes civilizaciones precolombinas, como la zapoteca en Monte Albán, dominaban la astronomía para regir sus vidas. El edificio J, conocido como el observatorio, es un testimonio de su ingenio, su forma y desalineación apuntan a eventos celestes, no a errores. Y el edificio P, con su cámara cenital, marcaba el preciso día del paso del sol, indicando el inicio de la temporada de lluvias. Una tradición milenaria que unía el cosmos con la vida en la Tierra, pero esa conexión con las estrellas se renovaría en 1970. El 7 de marzo de ese año, un eclipse total de sol cruzó el sur de México. Su franja de totalidad pasó sobre Oaxaca, despertando un interés sin precedentes. Miahuatlán de Porfirio Díaz se convirtió en el epicentro mundial de astrónomos y curiosos. La fascinación fue tal, que científicos de nuestra ciudad hermana de Palo Alto decidieron hacer una donación que cambiaría el futuro de la ciencia en el estado. Así nació el Planetario Nundewi y el Observatorio Astronómico Municipal, ubicados en la cima de nuestro cerro más emblemático, justo al lado de donde se celebra la Guelaguetza. Desde hace casi 50 años, el planetario ha abierto sus puertas ininterrumpidamente, convirtiéndose en una visita obligada para miles de estudiantes.
Desde la entrada, al ver la imponente cúpula del Planetario Nundewi, hasta el lugar de tu asiento, se siente una vibra como si te subieras a una nave. Cuando se oscurece y da inicio a la proyección, sientes que estás bajando por el universo. Es una experiencia que se queda en la mente por siempre.
Ese asombro, esa curiosidad, ha sido la chispa que ha encendido vocaciones.
Mi nombre es Mayra Santiago Cortés y soy doctora en astrofísica, orgullosamente de Oaxaca, y quiero compartirles que la primera vez que fui al planetario Nundewi marcó mi vida, ya que ver toda la inmensidad del cielo, esas estrellas, los planetas y galaxias, fue algo que me motivó a estudiar astrofísica.
El Planetario Nundewi no solo muestra las estrellas, sino que siembra en los corazones de los niños la semilla de la ciencia.
Despertó interés en aprender más sobre el cosmos y todo lo que todavía no conocemos. También me hizo sentir que aunque somos pequeños, en comparación con el espacio, somos parte de algo increíble y gigantesco.
Muchos de esos pequeños, hoy ya adultos, han elegido una carrera científica gracias a esa primera visita.
Entrar a un planetario por primera vez fue una experiencia increíble. La oscuridad te envuelve, pero no es una oscuridad amenazante, sino es una invitación a mirar las estrellas. Esta experiencia me marcó y me inspiró para estudiar física. Ahora trabajo en el Instituto de Física de la UNAM y quiero agradecer profundamente al Planetario Nundewi por inspirar a tantos niños como yo que en Oaxaca aprendieron a mirar las estrellas a través de ti.
Son astrofísicos, ingenieros y biólogos que llevan la magia del Nundewi a todo el mundo. Con un proyector análogo Goto, fabricado hace 75 años, el Planetario Nundewi sigue operando con la misma magia que fue donada hace medio siglo.
Inspiración en querer descubrir cosas nuevas, porque aunque el espacio es gigante y misterioso, me gustaría conocer más sobre sus secretos. Siendo infinito, hay mucho por investigar y explorar.
Es un lugar donde la ciencia se encuentra con la tradición, donde el pasado prehispánico y la tecnología moderna se unen para seguir maravillando a las nuevas generaciones desde el corazón de Oaxaca. Es un monumento a la curiosidad humana, a la ciencia y al amor por las estrellas.
Esto me lleva al Planetario Nundewi, donde conocí a personas que me han apoyado y me han guiado en la observación y descubrimiento de este universo.
El Planetario Nundewi es más que un edificio. Es una puerta al universo y un guardián de sueños. En un mundo donde la tecnología avanza a un ritmo vertiginoso, este proyector análogo sigue recordándonos que la verdadera magia de la ciencia reside en el asombro.
Ver proyectadas todas esas estrellas, planetas y galaxias fue como viajar a otro mundo, a un lugar fascinante y mágico, lleno de misterios donde todos estamos conectados con el universo aún siendo tan inmenso.
Su legado no está solo en las estrellas que proyecta, sino en las mentes y corazones que ha tocado. Es la prueba de que el conocimiento, cuando se comparte con pasión, es la luz más brillante que podemos ofrecer a las futuras generaciones. Es la historia de Oaxaca mirando al cielo y encontrando en él su propio reflejo.
Amazing. That was from Mexico. I'm really happy that we have the opportunity to share with all of you this amazing place. I'm really happy that Mexico is joining here. So also we are one of the persons in the video is a Konoc from Mexico. So I'm really happy that you have the opportunity to see this video. Right now we are going to continue with the next video also.
Saludos. Nosotros somos del Planetario Digital Chimalhuacán. Estamos en México, cerca de la Ciudad de México, y en esta ocasión tendremos una pequeña muestra de lo que es nuestro espectáculo llamado Bellas Artes en la Astronomía, con la sesión número 3 de pintura llamada Las Noches Estrelladas. En esta sesión de funciones especiales nosotros relacionamos cada una de las bellas artes con la astronomía. Pero es momento de comenzar este recorrido, así que vamos a viajar directamente fuera de nuestro planeta. Y aquí nos encontramos en nuestro planeta Tierra. Como les mencionaba, les saludamos desde México. Nosotros sabemos que vivimos en un planeta lleno de vida, que tiene ríos, valles, bosques, selvas. Está todo lo que queremos y que nos quiere, todo lo que nos interesa y nos preocupa, y que han nacido personas excepcionales como Vincent van Gogh, quien pintó unas de las representaciones artísticas por medio de la pintura más reconocidas a nivel internacional. El uso de los colores tan vivos, la técnica, ha hecho que muchas personas la vean maravillada, y en esta ocasión nosotros viajaremos a través del espacio para conocer a estos puntos luminosos que Vincent pintó hace ya mucho tiempo. Así que vamos a viajar de nuevo hacia una estrella, y en esta ocasión viajaremos a la constelación del Boyero. Viajaremos a una estrella gigante roja, una estrella muchas veces más grande que nuestro propio Sol. El Sol es la estrella más cercana a nosotros, y aquí podemos visualizar a Arturo, que, como les menciono, es la parte de la constelación del Boyero. En total tenemos 88 constelaciones con las cuales se divide el cielo nocturno. Y aunque nosotros estamos en el ideario colectivo acostumbrados a observar a las estrellas como figuras de 5 picos, la realidad es que las estrellas son esferas gigantescas de gases, principalmente de hidrógeno. Y es este hidrógeno que por medio de la fusión nuclear pues emite mucha luz y calor. Aquí podemos ver algunas de las constelaciones que cuando nosotros estamos cerca del planeta Tierra, pues las identificamos. Y dependiendo de la contaminación lumínica tendremos diferentes cantidades de estrellas que observaremos. Pero aunque pareciera que están todas alineadas a la misma distancia, la realidad es que no. Cada una de estas estrellas se encuentra separadas miles de millones de kilómetros unas respecto a otras. Y ahora, si yo les dijera que estamos en una nave espacial real, ¿me creerían? Veámoslo de esta forma. Nuestro planeta orbita alrededor del Sol. El Sol se mueve en el interior de una galaxia llamada Vía Láctea. Y esta Vía Láctea tiene al menos 100.000 millones de estrellas, la cual, aunque se ve gigantesca, e incluso así la podríamos percibir, en realidad es un pequeño puntito suspendido en la vastedad del universo. Aquí cada uno de los puntos amarillos que estamos observando ya no son estrellas, son galaxias, las cuales contienen también miles de millones de estrellas, y la mayoría de estas estrellas tienen sus propios sistemas planetarios. Aquí podemos contemplarnos ante la majestuosidad del universo. Pero es momento de regresar a nuestro hogar, de contemplar nuevamente nuestra nave espacial, ya que es aquí donde nosotros habitamos y existimos. Tal vez, y como sugerencia, tal vez y solo tal vez, si lográramos ser más amables los unos con los otros y dejáramos de tomarnos todo de manera tan personal, tal vez y solo tal vez lograríamos grandes cosas en conjunto, como por ejemplo mejorar la calidad de vida de todas y todos sin dejar a nadie atrás. Nosotros habitamos este pequeño hogar, este pequeño lugar, pero lo compartimos con muchas personas, muchas especies de animales, vegetales, insectos y demás. Más nos vale aprender a llevarnos de la mejor manera posible con toda la tripulación de esta nave espacial, y también aprender a cuidar de nuestro hogar, ya que de no hacerlo podemos ponernos en gran riesgo. Bueno, pues así termina nuestro breve recorrido. Muchas gracias por su atención.
Hello, my name is Natalia. I'm studying physics in Universidad de San Carlos de Guatemala, and this year I am honored to be Guatemala's node for 100 Hours of Astronomy. For this live stream, I decided to reach out to two amazing astronomers from Guatemala who have been huge inspirations to me, and I asked them, if you had to convince your younger self to pursue astronomy all over again, what would you tell them? Hopefully, they will convince you as well. Here are their answers.
Buenos días, mi nombre es Edgar Cifuentes, profesor de la Escuela de Ciencias Físicas y Matemáticas en Guatemala. Este video lo hago para motivar a las personas que quieran participar en astronomía. En Guatemala, durante mucho tiempo era muy difícil dedicarse a hacer astronomía, pero en los últimos años hemos ido mejorando las condiciones dentro de la universidad. La sociedad se ha vuelto un poco más receptiva hacia este tipo de profesiones, y entonces creo que ahora sí tenemos una buena oportunidad en Guatemala de poder retomar una tradición que ya en estas tierras se había desarrollado mucho con la cultura maya. Nosotros habíamos tenido un gran desarrollo de observación de los astros y de registro de los mismos, que todavía queda en algunos de los documentos que han sobrevivido. Y ahora también ya se ha iniciado mucha investigación en esta área, y hace falta que se vaya sumando más gente y que se vaya extendiendo a otros lugares del país y no solamente en la ciudad capital. Bien, esta es una pequeña contribución para tratar de motivar a algunos estudiantes a que participen de esta gran aventura que es el estudio de la astronomía.
Well, answering, if I had the opportunity to meet with my younger self and talk about pursuing a career in astronomy, what will I tell him? Well, I will say, go ahead. Astronomy is a really, really nice part of life. I mean, you have the chance to learn about the universe, about the physics behind the universe, about how we can explain different phenomena. That is wonderful. Also, not just learning about physics, you are learning about extreme cases of physics, extreme gravity, extreme energy regimes, and that's really, really exciting. also you are lucky because you get to know a lot of really wonderful persons. Well, I had the opportunity to work with really, really great researchers, also to receive wonderful classes with my former professors. I learned a lot. Also, I learned different ways of working. You apply what you learn in the path of astronomy to your life. I mean, you get you translate about the ways of working, about the ways you decide something in work, about how do you decide things in your life, and that is really, really nice. Also, because you enjoy your work, you work a lot. I mean, that's not bad, and you do it because you are enjoying what you are doing. I mean, you work every day because you enjoy it. Also, you have the chance to teach the younger generations, which is a huge responsibility because they are the bright minds of today and of later. And but also you get to learn a lot from the students too. I really enjoy teaching, and it will be an awesome path to follow. So go ahead, study astronomy. It is awesome.
Hi, everybody. We have one special addition to this session today. This is from our NOC, from our National Outreach Coordinator from Sri Lanka, showing off his the engagement work that they do over in Sri Lanka. If I can find it, that would be fantastic. While I'm looking for this, Minette, do you want to come online and have a little bit of a conversation with me while I'm searching through my file?
Yes, of course. Yeah, I'm very excited because we have seen some videos from Mexico. So I'm really happy to share all that with you. Mexico is very, very big, and one of the efforts that we are trying to do is, like, in different regions, we are trying to unite all the astronomy efforts that we are doing. So it's great that you have seen 3 different places from Mexico, but we have several more, so that's amazing.
Yeah, it's true. And it is really amazing too, the differences you can see across countries and across nations. It's one of the things that we really try to encourage when we have national outreach coordinators for a country. We want them to work in teams and to work together to engage as many people across the country as possible. And I think Cindy has actually really done a fantastic job of modeling what this could look like with the NOC team that she's assembled in Mexico. A really diverse group of people and researchers and science communicators from really diverse backgrounds, really geographically diverse places as well. So I think that's what we should strive to do here at the Office for Astronomy Outreach is try to expand our network as much as possible. And so this next video I'm going to show is from our NOC that's the National Outreach Coordinator for Sri Lanka, who's a new NOC this year, started at the end of last year, yeah. So I will go ahead and share my screen and let him take the stage.
I'm Mr. Dominic from Sri Lanka Planetarium and currently working as a lecturer in Sri Lanka Planetarium and also NOC for the Sri Lanka in the IAU. So let's talk about first about the Sri Lanka Planetarium. That it is starting on the part of the exhibits that of the industrial exhibition that will happen on the 1965. So you can see that our planetarium is in this here, and as the permanent exhibits of this industrial exhibition that happened on the 1965. So in this planetarium is constructed by and the main design was designed by the engineer N.S. Kulasinghe, who is a prominent engineer in Sri Lanka, and this planetarium was built the special construction method that we call as the precast. So within 10 months of period that this full construction was completed, and also this is the person that who built the our planetarium, that only planetarium in Sri Lanka, and he had some not only this is planetarium, so he had some constructions he did, among them that this is the some prominent examples for his contributions to Sri Lanka. So this is the stupa, both stupas, and this is the stupa at the Colombo Harbour, and this one is the another stupa at the little bit down south, down from the western region. This is Kalutara. Okay, so when we are considering the shape and the measurements of the planetarium, so our planetarium is the one of the largest planetariums in the world. This is the height about 21 meter height and almost 23. So diameter of this the dome that they are around 23 meter diameter, and also this the shape of this planetarium is there's some lot of discussions there. So when we are looking at the aerial view of this planetarium, that we can see that as the blooming lotus flower, and but in the designer, who is the Dr. E.N.S. Kulasinghe, thought that this is kind of that Red Indian's heart. So you can see the Red Indian hearts. So they constructed their hearts with these sticks, and all the sticks are lined together at this point, and same as that our planetarium that you can see here. So all the beams are attached in this part. So there are about actually this masterpiece having some unique view, and yeah, this is a very attractive place. So inside this dome that we have some several projectors, optical and digital as well, and in the middle of the planetarium, the dome that we can see, the universal projector is the Mahal size Jena 4. So one of the only active all kind of planetarium, all kind of universal projector right now is a working condition. So this is the kind of the Mark 4, Jena Mark 4, and there are about 65 inbuilt projector inside this universal projector. So right now is a very good in condition, and also the everything is smoothly functioning right now with this projector. So I know that most of the planetarium having the new technology for projecting the night sky. Within this universal projector, that we can recreate the night sky as it is, like very realistic. So here the image or photo of the universal projector that which is on the center of our door, like this that you can see. So our projector, main projector, that universal projector is in here, and also the recently, that means not the recently actually, it's a 10 years back, 2014, that we installed the another digital projector systems that we call full dome projector systems. The Saudi full dome projector system is in the here, and this is the southern part of the projector dome, and also the north part. So we have together, there's a two projector in the movie, full dome movie into the planetarium sky, and we recreate the full dome movie. So this is the one of the movie that we showed in here. So you can see the audience, or like seatings. There's about 550 seating area or seatings there. So one of the largest seating capacity of the planetariums around the world. So here that you can see another projector that we projector in the solar eclipse, as it is that we can see in the nature realistic projector. Yeah, of course. So altogether that we have almost 60 or 70 or 80 projectors that we recreate the natural beauty of the night sky as it is for the audience. So normally that we have the two shows per day, 10 a.m. and the 2 p.m. So the the length of the our show is about 1.5 hours. So we are conducting in that our three languages, like single, that is our mother tongue, and also of course the English and the Tamil as well. Right. So not only the planetarium and that in the yard or planetarium premises that we have the technological park, that we have the 16 kind of physical exhibits or demonstrations exhibits for about the science and the physics as well, that you can see the students from the country, they are playing together and they getting experience about the these exhibits or from the Technopark. Okay, so that's all about the Sri Lanka Planetarium, and I invite you all that you are in here in the worldwide. So visiting in Sri Lanka, and also don't forget to visit the Sri Lanka Planetarium, that you can get the massive experience with the the unique and the monumental structure and the content and everything. Okay, so that's all about my presentation. Thank you very much.
So now I think we have some time before our last talk for this session. Manette, I think you have something very exciting to show everybody. Where are you right now?
Yes. Hello, you can hear me, right?
Yes, we can hear you.
Oh, perfect. Yeah. Well, right now that I joined to the live, I am in the astrobiology lab in the Astronomy Institute. So I want to get a little chance, like, to show you things around in the lab. I can show you some of the instruments that we have, and also some of our outreach activities that we do.
Amazing. I'm going to give you the floor so you can show everybody everything that you're doing.
Perfect. Thank you very much. I am going to switch my my camera. So let's see. Yes, perfect. Okay, so this is the astrobiology lab. I'm going to show you little things around. Sometimes we see in the movies how are the labs, and probably they look so clean and tidy. Of course, that is very important. But here we are also doing a lot of experiments. So depending on the day of the things that we are doing, we have a lot of things. So first, I want to show you. I'm going to start over here. One of the tables that we have. We are having here some microscopes, some also some samples. I'm going to try to zoom in. We are here. These are one of the samples that we got from Ensenada in Baja California, Mexico, where we are extracting tardigrades. So what we usually do is that we collect the samples, we got them in some water. So after some hours, we can see them in the microscope where we are looking for tardigrades. So that is one of the mainly activities that we do on this table. We are also
slow down.
over here.
You're just talking about tardigrades.
Instruments that we use. We obviously we have different things here. Where, for example, here is where we grow some cultures from bacteria, also for some plants, and we have some people that are working here with their slides. We are trying to see some parts of the plants, because as you can imagine, we are trying to study in astrobiology some extreme environments. So we are trying to see all these microscopic samples, and they are pink because we add some color to see some structures. Also, one of the things that I like the most and I really enjoy here in the astrobiology lab is that we have an UV chamber radiation. So with this, we are trying to simulate some of the radiation that some planets are getting. So here, for example, we have done some experiments exposing some tardigrades to Mars radiation. As probably you know that we see Mars, that it's a red planet without atmosphere. So the thing that it doesn't have any atmosphere is that it's getting a lot of radiation. So that will be a very extreme environment to survive. So we are experimenting with tardigrades. I'm going to try to open it so you can see the chamber. It's actually, you can see me there also. Here in the middle of here is where we put the sample, and we can control the time that we expose the samples. We are also trying to simulate some of Europa's moon's radiation, and what's one of the researchers that we are trying to do. And here also we have some instruments, so we can measure some pH, also temperature, salinity. So this is like the experiment station. We have also, when we have some visitors to the astrobiology lab, we have some samples from different organisms and animals, but also I'm going to try to show you, we have some spiders around, but also we have some meteorites. We have also some fossils from different places. I think I have some, this one. Yeah, well, we have a collection of rocks. It's very, very funny that these are samples from students that when they are on the field, they are collecting some rocks and samples, and they bring them to the astrobiology lab so we can show them. And also for the things that when people are visiting us, we have some outreach activities. So for example, like today, we are receiving a public that are going to visit our lab. So we are trying to explain about tardigrades. So we have a little tardigrade here. So we are trying to explain that we have also our camera, UV camera radiation, and we are explaining how we put these tardigrades inside. But what are we studying about the tardigrades? It's about their molecules, about their DNA. What are the proteins that are helping them, that it's called the SOP, to survive to these extreme conditions. So we are trying to show like this tardigrade, and we are also having these protein models that some students made. So that's one of the activities that we are doing. Also, we have some models of the tardigrades in 3D impressions. These are very helpful for us because we have different shapes and forms from the tardigrades, and this is one of the ways that we can use to show the different forms on the tardigrades. So you can see, as in this sample, you have the tardigrade with its claws. Probably I'm going to do a zoom to the claws. So that's very very entertaining for the public, and to know also to learn more about the tardigrades. Around here, I also have, since we are studying different moons and planets, etc., I also have this little model about Europa Moon, so we can show how is the surface, how do we usually see it in the pictures. And also one of the things that we want to show about Europa Moon is that it has a liquid ocean beneath this icy surface. So in this model, like, we can show it both. We can show how it's the surface, and we are trying here to represent all this liquid ocean beneath the icy surface, and also the core with the inside the moon. And we added this these little plastic tubes because we want to have this water inside, so it can be also a surprise for the public, where you can see some vapor coming out from the Europa. So as you can see, we are like trying to use a lot of creativity with simple materials, but we can show bigger concepts of astronomy. So one of the things I can show you here also is we have this chamber that I'm going to make a little sum about it. We have a lot of samples. All of these are little tardigrades, but we also, in this chamber, we can control different things about, let's see, about light. We can also regulate some temperature and humidity. So we are trying also to replicate some extreme environments. So as you can see, I think that it's a small place, but we are doing a lot of activities. And actually, this is like my day-to-day routine, and I'm really happy and excited to share it with all of you.
That was so cool. Thank you so much for that. I tried to get your attention because I wanted to learn more about the tardigrades. You got it in the end. So while you're getting back to your workstation there, I'm gonna just introduce quickly our final speaker for this hour, Kumiko Saraseto, who's gonna talk to us about Subaru telescope, another telescope on Mauna Kea.
Hi, Kelly. Can I start?
Yes, please do.
Oh, okay. Hi, aloha kakahiaka. Good morning, everyone. It's 6:50 in Hawaii, Very nice to see you. My name is Kimiko Sasato, a Japanese astronomer or a public outreach specialist at Subaru Telescope, National Astronomical Observatory of Japan, NAOJ. Today, I want to share Subaru's digital content, which you can enjoy anytime, anywhere. One of our goals is to make our content accessible to people in the world. We also have social media accounts like X, Facebook, Instagram, and YouTube. Please follow us. And last year, we celebrated the 25th anniversary of the Subaru Telescope since its first light in 1999 on Mauna Kea, Hawaii. We held a variety of events both in Japan and in Hilo, Hawaii. Some digital contents are related to the 25th anniversary events. Okay, so I will bring you to our website. This is our homepage, Subaru Telescope homepage. Just Google Subaru Telescope or type subarutelescope.org/en. En means English. Actually, and when you scroll down, you see many digital contents like this one. As one of the 25th anniversary project, we improved the web design and digital contents are more accessible to you. At first, I want to start from, we have some kids contents, but today I want to start from Subaru Telescope 3D virtual tour. This is our virtual tour in Japanese and English. When you scroll down, and please click, Let's Explore. We developed this 3D tour because even local people in Hawaii, it is very challenging to go up to the Mauna Kea and see the Subaru Telescope, and also for Japanese people or people in the world. So we developed the virtual tour. You can enjoy the tour on your PC or on your VR, virtual tour, virtual reality goggle, anytime, anywhere. So this is our screen of Subaru virtual tour. So you see the Subaru Telescope over here. It's a giant telescope. Its tall is more than 20 meters, and this is Subaru's primary mirror. Its diameter is 8.2 meters or 27 feet. It is one of the biggest monolithic mirror in the world. So at the virtual tour, you see some white circles. Please, white circles here, and you can walk inside of the Subaru Telescope enclosure. So this is one of our instruments at Cassegrain Focus, and also you can look up our giant monolithic mirror over here. This is the first digital content you can enjoy Subaru Telescope anytime, anywhere. Let's go back to our Subaru homepage. Next digital contents is this one, Mauna Kea Star Live Camera. And thank you so much for using this live streaming in this program. Let's click over here. Okay, so this is, okay. So Subaru Telescope has been collaborating with Asahi Shimbun, a Japanese newspaper company, since 2021 to set up this 24/7 live streaming camera. So you can see the view and the starry night of the summit of Mauna Kea anytime, anywhere. So this is the first Subaru Asahi Star Cam from Mauna Kea. This camera is mounted in the Subaru Telescope facility on Mauna Kea. It's toward eastern sky. So you can see other telescopes, observatories of Mauna Kea. The two large Keck telescope next to our Subaru, and you see IRTF, NASA Infrared Telescope Facility, and it's sunrise time. It's very hard to see, but you can see CFHT, Canada, France, Hawaii Telescope, and Gemini Nose, and University of Hawaii 2.2 meter telescope. And this February 2025, CFHT, this telescope, this observatory, added the second live streaming camera in collaboration with Asahi Shimbun Company. So if you are interested in many live streams from Star Camera, please visit Asahi Shimbun, Asahi Astro Live YouTube channel. So, and click live. You see Now, you see many live streams, not only from Mauna Kea, but also many places in Japan. So I introduced our Subaru Asahi Star Cam, this one. Mauna Kea, mounted at Subaru Telescope facility, is towards the northern sky. The second one, CFHT Asahi Star Cam, is this one. I click here. Look, so the Subaru Asahi Star Cam is toward the northern sky. CFHT Asahi Star Cam is towards the western sky. And you can see our Subaru telescope over here. Subaru telescope has a very unique silver cylindrical dome. And also, to Keck telescope, NASA IRTF, and we also have some radio submarine telescope like JCMT, James Clerk Maxwell Telescope, and SMA submarine array. Okay, and I have one more announcement to you just for this event. Today, since last night, we started the third camera just for this event. So, just for this event means 100 hours of astronomy, 24 hours of planetarium event. Please go back to Asahi Astro Live YouTube channel and click this one. Mauna Kea, Hawaii Special Live, October 3rd. Presented by IAU IPS, International Planetarium Society, just for this event. So my colleague set up this special camera toward the northern sky from the Subaru Telescope facility. This camera works until October 6, 6 a.m. in Hawaii or 4 p.m. in Universal Time. Please enjoy views and starry night of Mauna Kea with the 3-star cams during the event. And I have 4 more minutes. Let me introduce our 25th anniversary event. We have many contents. Please click topics and announcement. We publish our report of last year. So we did a bunch of events. So we developed the special design just for last year. We developed the 5-minute commemorative video celebrating 25 years of the Subaru telescope. And we held a special exhibition in Tokyo, Mitaka, Japan. And also in Hilo, we held the first Tanabata block party. This is a kind of joint open house day of Mauna Kea Observatory's Hilo-based facilities. So we send our appreciation. Mahalo means thank you in Hawaiian language. So we invited local people to our base facility and show who we are, what we are doing. This event is very popular. So this Tanabata block party became an annual event of Mauna Kea Observatories. We held the second Tanabata block party this August. And we published the image collection, adding new beautiful images. Sorry, this is written in Japanese and sold in Japan only, but even if you cannot get it, you can see the beautiful images of Subaru at our Subaru Gallery. Please click Subaru Gallery. Actually, we have just renewed the top design of the gallery page, so you can see the beautiful image very easily. So last year, we added 2 astronomical images per month, and this year, we add 1 photo of Mauna Kea and 1 astronomical images every single month. So please visit our website and feel free to download beautiful images of Mauna Kea and celestial bodies captured by the Subaru telescope. And if you are interested in high-resolution image, please contact me. And the last, not just Subaru, but our NAOJ are now collaborating with the Pokemon company to hold the very special traveling exhibition, Pokemon Astronomical Observatory. It will for about 3 years. It will start on next month, November 1st, close to Tokyo. If you love astronomy and Pokemon, please visit not Subaru, but NAOJ, our headquarters website, and read this article. Thank you so much. So please enjoy Subaru telescope anytime, anywhere.
Thank you so much, Kumiko. That was really, really amazing. And we will be showing that special live stream a little bit later, facing north, Mauna Kea. And so now I think we're going to move on to the next hour, which is very exciting for us. So who is our next moderator? Guatemala, are you here?
Yes, indeed, Kelly.
Wonderful.
Blue skies, everyone.
I love your background. Oh my goodness gracious.
Yes, indeed. It's very important for those of you who are not familiar with this publication, CAP. This is the publication for all of us doing astronomy outreach, especially with this special edition, by the way, about the 100 years for planetarium, which is, of course, the topic of our event. I must say it's quite an honor for me to be part of this segment, where we're going to have participation of truly very talented people around the world. We're going to have people from Turkey, from Mexico. Hola. We're going to have as well people from Argentina, Philippines, Algeria. And of course, we're going to have a very interesting talk with Dr. Shannon and Dr. Kelly Blumenthal. So if this is okay for all of you and our production team says anything else, I'd like to introduce you to Dr. Sinan Alice from Istanbul University, Turkey. By the way, he is the national outreach coordinator there. Very interesting job he has done. So it's to you, Dr. Sinan.
Hello everyone. From a nice Istanbul evening, I'm just greeting all of you, all the IAU team. You are just seeing behind me a bit dark, I know, but I'm going inside in a minute. You are just seeing our historical dome. This is the first observatory in the country from the 1935. So we are an astronomy department here, and we have the only and the first planetarium in an astronomy department in Turkey. And now I am going to show you our little modest planetarium with the 39 seats. So I will introduce you to my friends just in a minute. I'm so sorry. So I will show you the entrance of this our department. So this is the entrance of our planetarium, and these are just the movies that we are showing. Some of them the ESOs and movies. We have translated them to Turkish actually, and with the voice. So this is our entrance to planetarium, and I will introduce you two of my friends. One is a colleague of mine, Süleyman. Süleyman is going to tell you about how we use this planetarium in the context of the National Astronomical Olympiads.
Yes. Hello everyone, greetings from Turkey. I'm really honored part of this global event today. I am Süleyman, research assistant at this department. We use this planetarium for public outreach events and also some activities and some projects, and also addition to for our courses we use this planetarium. We provide some hands-on activities for our astronomy courses, and also we use the planetarium to train our Turkish National Astronomy Olympiad teams. As you know, every year different countries organize the International Astrophysics Olympiad, so it means we should train our students for the different sky. So we use this planetarium to train the students by simulating the night sky different countries.
Yeah, especially if they are not used to the southern sky, for instance, for our case. In the last 2 years, it was hosted in Brazil and it was hosted in India. I mean, this last August. So we need to try to train our students in the planetarium for the southern sky.
Yes.
Thank you, Süleyman. And my next friend is our undergrad student, Nisa. Hello, Nisa. What you are doing here? What is your job?
First of all, I want to say hello, everyone. I am Nisa, and I am undergrad student at Astronomy department. We are the organization team as Amateur Astronomers Club, and we host so many people of all ages within the scope of public outreach, and most of them are students. We have lots of films in this planetarium, and our guests are watching this film, especially when they're primary school students watch the film, they go crazy, they are impressed, and seeing smiling on their face motivate us to do more than that. Yeah,
Okay.
that's all.
Thank you, Anissa. Let me also give you a few insights about the planetarium. This is a very modest planetarium, but we are using 10 projectors here to combine the image. We are using the video mapping technique, and we are hosting, as Nisa told you, we are hosting regular visits for the students from the whole kind of schools, from the whole grades, from the 6th grade or even smaller ages actually, to the high school. And in the daytime, we are hosting this event. And also our students, undergrad and graduate students, are also benefiting from the planetarium, because sometimes we are showing them some, advanced movies, advanced, visualizations here to support and contribute to the lectures they are having. And that's all actually from Turkey. If you have any question, I can answer, but I don't know, I cannot hear you at the moment. Let me show you again. Are you there? Okay. Hello? Are we still in the broadcast?
Yes, you're still here.
Great. So this is our entrance. Still we are there. Do you have any questions? Do you want to know anything else?
I'm sure the audience is quite interested, Doctor, but the thing is, given the fact we have a 5 minutes delay with YouTube, maybe the questions will come later.
Sure.
Congratulations on your magnificent job and including all your team in it. I think this is quite inspirational with everyone who is following this broadcast. Thank you very much.
Thank you too. Have a nice broadcast.
Clear skies, Dr. Shannon. Dr. Sinan, I meant. Okay. Well, getting back to the studio where we are, now it's time to share what Dr. Ernesto Aguilar Rodriguez has been doing. He's part of the Universidad Nacional Autónoma de Mexico, which is the autonomous national university here in Mexico, part of the group of heliophysics and space weather. And please, back to you. Okay. This is just to highlight that this is happening totally alive. Okay. So eventually, yes, now it's the time to share. Okay.
Y el lente de arriba lo proyecta a la parte de la hoja, exactamente a la hoja. Y esos tres puntitos que ustedes ven ahí son los puntitos que vieron en ese otro telescopio y que pueden ver en algún otro. Esas son las manchas solares. Entonces es una manera muy segura de poder ver eso.
Se ve como la luna.
Se ve como...
Hola, pues antes que nada, muchas gracias, agradecer la invitación. Yo soy Yavira Bristututi, coordinadora municipal de Ciencia y Tecnología. Estoy muy contenta de participar en este tipo de eventos.
Ver ahorita que van a pintar se llama el sistema solar. Esta es una representación.
La verdad es que a mí me intrigan mucho los agujeros negros. Esa idea de que hay un punto en que todo puede desaparecer, me parece muy intrigante, muy fascinante. ¿Qué hay detrás del agujero negro? Y pues es algo que aparentemente nos vamos a tardar mucho en investigar, en poder saber y descubrir, pero el misterio ahí está y eso la verdad es que me intriga mucho. Que no tengamos luz, podríamos estar apreciando el sol. Bueno, pues les doy la bienvenida a este recorrido donde nuestros compañeros de Lanka nos están invitando a conocer, a disfrutar de todo lo que es la ciencia y lo relacionado con nuestro espacio, pero particularmente con el sol. Y gracias a la tecnología es que ellos tienen todo este conocimiento que lo están compartiendo con nosotros. Y los chicos sigan disfrutando, los invito a que sigan estudiando. Cada vez que tengamos una oportunidad de disfrutar de un evento como este, pues la aprovechemos. Muchas gracias por asistir y pues sigamos disfrutando. Pues muy interesante, muy certera a este tipo de actividades, porque la verdad es que cuando ya hacen algo de manera lúdica que pueden manipular, observar más, de forma más directa, es como se puede incentivar a que los chicos sigan estudiando, que se adentren a la ciencia, que sigan motivándose para seguir estudiando sobre esa guía. Claro que es importante que se estudie todo, ¿verdad? Pero esas semillitas de ciencia que es para mí, a mi punto de ver, muy importante seguirla sembrando en cada pequeñito que visita eventos como estos.
Entre los planetas en general, ¿sí? Por ejemplo, vamos a suponer la distancia que hay del Sol a la Tierra. La distancia que hay del Sol a la Tierra, ¿cuántos kilómetros creen ustedes que hay? Aquí lo viene bien en el libro, pero lo vamos a explicar. La distancia que hay de la Tierra al Sol, nuestro satélite más cercano, son 346 mil kilómetros.
todo lo que estamos viendo está hermoso. Estamos viendo planetas, soles, estrellas y etcétera. Varias cosas sobre el espacio que está arriba de nosotros.
Felicitarlos y hacerles la petición de que no dejen de hacer estas actividades, que se hagan más seguido y pues muchas gracias y felicitaciones.
Wow, it was wonderful, right? Wonderful. If you're not familiar with him, Dr. Ernesto Aguilar spends time doing his research, and he's a very famous one here in Mexico. And as well, he dedicates time to do his outreach activities, right? Quite important, especially for the kids. I'm sure you appreciated how happy everyone was during this experience. Dr. Stefania Coluccio-Lesco from Planetarium Galileo Galilei in Argentina. She and her team has prepared something quite interesting as well for her community and for the entire world as well. So, cameras with you, Doctora.
Bienvenidos al Planetario Galileo Galilei de la ciudad de Buenos Aires. Soy Estefanía Coluccio, la directora del planetario, y estamos celebrando las 100 horas de la astronomía. Es un placer compartir con todos ustedes este maravilloso ícono de la ciudad y este lugar tan especial que todo el mundo adora y que tiene la misión de promover la curiosidad y el placer de aprender sobre el universo y la naturaleza. Espero que les guste este video y los esperamos cuando quieran.
Gracias Planetario por invitarnos, nos encantó. Mamá y papá vinimos de chiquitos y fue como volver a vivir algo hermoso. Los chicos lo súper disfrutaron. Todo el staff súper atento a todo, estamos re contentos. Gracias por la invitación.
Estamos acá en el planetario, trajimos a las nenas, está hermoso como siempre. El chico que guía un genio, estamos volviendo a aprender de alguna manera, cosas que ya habíamos olvidado. Súper recomendable para todos, que vengan en familia.
Vinimos a ver la función de Veo Veo, la función accesible. Agradecemos la propuesta, si no sería un poco difícil poder acceder por el tema de que, bueno, necesitamos esto de la distensión, que algunas luces estén encendidas y realmente nos encantó. ¿Quieren volver?
Sí.
Sí, queremos volver, gracias.
Estoy acompañando a dos grupos de séptimo B y C. Y bueno, nos encantó la propuesta, creo que les gustó, ¿no? Los felicito por este espectáculo.
Nos inscribimos porque coincidimos en que todos somos aficionados a la astronomía y queremos aprender justamente a disfrutar del cielo, de lo que vemos, de la naturaleza. Y la verdad que nos gustaría aprender eso, a disfrutar del cielo.
Wow, lovely, lovely. And in case you're not familiar with it, I recommend you all to take a visit to this Galilean Planetarium at Buenos Aires, Argentina, considered among the most beautiful planetariums worldwide. They're doing a wonderful job. And as Cynthia mentioned this some hours before, we are rotating in this lovely planet we call home, and now it's time to move into a different country. Quite interesting indeed, to the Philippines. Maria Rosario Ramos from Dos Pagasa, the office, quite important the job they are doing with locals. They have prepared a very interesting material and content that they are about to share with us as well. So it's to you, Maria Rosario.
The first planetarium in Southeast Asia was established by DOS de Pagasa in 1954, located at the University of the Philippines Diliman campus, alongside the Pagasa Astronomical Observatory. It was equipped with a Spitz-type projector and could accommodate only 25 people without permanent seating at the time. In 1975, the National Planetarium located in Rizal Park, Manila, was established. It was owned and operated by the National Museum of the Philippines. On October 11, 2021, the National Planetarium was officially closed to the public, and its building was decommissioned to give way to development plans by the National Parks Development Committee. The Pagasa Planetarium in Quezon City, which opened in 1977, originally featured a Minolta MS-8 projector and seated 88 people. Today, it has been modernized with a digital projector capable of simulating both daytime and nighttime skies, providing stunning visualizations of various celestial objects. It can now accommodate up to 100 people. The Nido Fortified Science Discovery Center opened in 2007 at the Mall of Asia in Pasay City, featuring a digital planetarium. It was rebranded as the Explorium in 2014, but permanently closed in 2017 as part of the mall's expansion. The Mind Museum, which officially opened to the public on March 16, 2012, features a planetarium as part of its Universe Gallery. This special section, sometimes referred to as a space shell, offers an immersive experience where visitors can lie back on reclining couches and watch shows projected on a dome ceiling. The Mindanao Planetarium, the second planetarium built and operated by Pagasa, is located in El Salvador, Misamis Oriental. The facility, which has a 100-person capacity and features a tilted dome projection theatre, galleries and telescopes. While construction started in February 2020 after initial delays, it officially opened on May 17, 2024. The Visayas Planetarium, located in Lapu-Lapu City, Mactan, is the third planetarium built and operated by Pagasa. Opened on March 17, 2025, the facility can seat up to 90 visitors and features a tilted dome projection theatre.
It's lovely, lovely. And again, as the planet is still rotating, I mean, we started from Turkey, then we moved to the Americas. We just watched this from the Philippines, and now it's time to move to Algeria, where Dr. Alik Mohamed Lamin, part of the Scientific League of Ejaya, has prepared something very interesting. By the way, he is a national outreach coordinator there in Algeria. So I presume this is going to be magnificent again. So cameras with you, Dr. Alik.
Welcome from Algeria. We are the Scientific League of Bejaia Astronomy Section. Today, we are proud to join the international community for the event of astronomy.
We have set up our mobile planetarium to share the wonders of the universe. Children and adults from our community are here to explore the stars, planets, and galaxies together.
Multiprise, appuyer. C'est bon? Ah, c'est bon.
في قبة فلكية واش فيها القبة الفلكية هذه فيها هاد الخيمة هذه وفيها داكور واش الفائدة تاع القبة الفلكية هذه واش هي الفائدة تاعها؟ نشوفوا القمر
Our goal is to inspire curiosity, bring science closer to people, and make astronomy accessible to everyone, no matter their age or background.
هذه الصور حقيقية. هذه الصور راح تشوفوا النجوم. هاي هذه الحركة الظاهرية تاع النجوم. ريسينا وين جاية؟ وش من ولاية؟ جاية وين جاية؟ الجزائر. في جنوب أفريقيا. الجزائر وين جاية؟ برا. في شمال؟ أفريقيا. صح. وهذه أفريقيا هذه وين جاية؟
Looking at the sky reminds us that we are part of something much greater.
أجرب ضرب الباب. هذا باش تعرفوا ولا مسكين.
I am very happy to be in this planetarium.
Through these activities, we connect people with the universe and encourage the next generation of scientists, dreamers, and explorers.
على بالنا هنايا رانا وش المدينة هذه ورانا هنايا؟
It is amazing to see planets, stars and galaxies.
La Ligue s'engage depuis plus de 30 ans dans une dynamique de la promotion de la culture scientifique. Notre mission vise à rendre la technologie et les connaissances scientifiques accessibles dans le contexte science pour tous.
We are proud to be part of 100 Hours Astronomy. Welcome to Bijaya every time.
Wow, thank you, Dr. Ali Mohammed. And all those wows coming from the kids are the best evidence of your talent doing your outreach activities. The name of this segment actually is Pathways to the Cosmos, and it's because of this that now we're going to have a live talk, a quite interesting one, I must say, with two gifted persons for this. We're going to have Dr. Shannon Schmoll. She is the director of the Abrams Planetarium at Michigan State University, and Kelly Blumenthal, which you all know is the director of the Office of Astronomy Outreach. So cameras on you, doctors.
Thank you so much. So this segment is indeed called Pathways to the Cosmos. And this is actually, I think I've been basically doing this the entire time that we've been on air with almost everybody that I've spoken to, because I just think it's so fascinating to understand how people got to where they are. And so Pathways to the Cosmos really is just about understanding all of the different ways that we have, arrived at our particular location, place, and time, the things that we're doing and the things that excite us. So I thought, since we're here celebrating the centennial of the planetarium, in an amazing planetarium that's behind me, you can't see it, but it's there. And, having Shannon here with us, Dr. Schmoll here with us to, join in the celebration and join in 100 Hours of Astronomy. It's just such a wonderful thing. And so, Shannon, I want to get to know your backstory a little bit better. Can you talk maybe about, when we were working on this, you kind of mentioned or maybe alluded to the fact that you had a kind of academic background in education, and maybe that kind of morphed into something that looked more like planetariums. But I want to hear it from you. How did you get to where you are?
So we can start by going way back, I guess, to when I was a kid. because in a way I've come full circle. So when I was little, what I really wanted to be was a teacher for a long time. And like that's what I always said, is like I want to be a teacher. And then by the time I got to high school, I was like, you know, I'm really interested in science. I think science is really cool. And I kept changing my mind on what science I liked. I grew up in Washington State, in Tacoma, just south of Seattle. And there's the Fred Hutchinson Cancer Research Center there. So that was a very like influential thing when I was growing up. So like at one point I wanted to be a paleontologist because dinosaurs are still cool. And then at one point I wanted to be a doctor, and then I wanted to be a pediatrician, and then I wanted to go into cancer research because of what I'd been exposed to. But then in high school, I had like this open fourth period class I had to put something in, and like the only thing I could put in it was physics, and I was like, I guess I'm taking physics. And I was kind of afraid of it, like, because I think the idea I had of it was something from Hollywood at the time, and like it's boring and hard and I would never be able to do it. And I took the class, and I had a really great physics teacher. And she made it a lot of fun and let us just explore that curiosity. And I loved being able to understand why things worked the way they did. And that sort of sparked something for me. And then I started reading, I think Scientific American, like I made my mom get me a subscription to that. And I started reading it, and like the coolest stuff is in space. That's where I want to be. And so that's where I started to get interested in astronomy. And so I went to college, I majored in physics and astronomy. I went to grad school. The intent was I was going to be an astronomer and do research. But along the way, both in undergrad and grad, I got to do outreach, and I really liked that. I got to do it in a planetarium, and I really liked that. When choosing which place to go to for grad school, I chose the one I chose for many reasons. Oh, cattail. Also kid in the background. So I chose it for many, many, many reasons, but one of them was the planetarium was better. And in fact, there were two on the campus. So I went to the University of Michigan, and I was doing astronomy research. I finished my qualifying exams, but I heard about this museum studies program, and I found myself daydreaming about working in a museum of some kind. And I really liked working in that planetarium. And then, oh wait, there's this program where you can kind of do a joint PhD. So I was able to add on education work. So this is a very long story. So I was able to do a joint PhD with astronomy and education. And so my graduate work and my thesis ended up being on integrating planetarium field trips into curricula. And so, and I got to do that museum studies program, which included an internship at the Adler Planetarium. And so like that was going to be like oh man, if I can get a job in a planetarium, I will be so happy. And first job out of grad school was at the Field Museum. I had a 1-year contract to make educational materials for a traveling exhibit on biomechanics. That exhibit, I think, is now a permanent one at there. There's a giraffe heart there, by the way, which is like my favorite thing. Go, if you're ever at the Field Museum, go check out this giraffe heart. But within a year, which was very good because this was a year-long contract, I had also gotten contacted about the job I'm currently at. And that's where I've been for 11 years. And in the end, I ended up back as a teacher of sorts. But I picked up all these other interests along the way that I get to use and apply.
That is so fascinating. I've known you for not a long time, but a little while, and I haven't heard that story before. It's really really interesting. And you're talking about like all the different things you wanted to be when you were a kid. I think I told my mom once that I wanted to be a fishmonger when I was older. I don't even know. I think she said it was like 4 when I said How I knew what a fishmonger was, I have no idea. But I think, it's just so interesting the like different paths we take. Well, not even just the different paths, but like the different ways that the paths diverge, and the small little perturbations that create a larger change in the long run of your final destination. Not even your final destination, it's just where you are at the present moment. Is just such a interesting culmination of all of the tiny decisions that you've made along the way. And I think that's really beautiful.
Yeah.
But now you are the president of the International Planetarium Society, which is pretty cool.
Scary.
So it's not scary. It's a distinguished position to have. So what are your responsibilities as the president of the International Planetarium Society?
I mean, there's the very administrative side of things, of like setting meeting agendas and meetings with our board and communicating, and part of it is working very closely with the hosts of the conference. So we have a conference every other year. A president serves as president for 2 years. So each one has a conference that they are supporting. So I've been working very closely with our hosts for the 2026 conference in Fukuoka, which I think we will hear more about it later, right? Okay,
yes.
It hasn't happened yet. But you'll hear about this really wonderful conference in this really wonderful city in Japan. And I had the opportunity to go visit this summer, but with my family. But a lot of it is also sort of looking at where IPS is and where do we want to go, and what infrastructures can we set to get us going there. And a large part of that is like, as president, it's really a 6-year term. So you come in for 2 years as president-elect, then you're president, and then you're past president. So you're kind of learning, you get to be president, and now you're there to kind of help everyone else after. And so Guillerme, who has popped up here and there throughout this, he's our president-elect. And so I try to make sure I'm working with him and knowing what he wants to see, so that we are trying to work together over those several years to make the organization stronger, to make it responsive to the changing field. Our technologies are changing a lot. The environments in which we all teach, sort of in the more like broader sense, is very different, but also very dynamic. And so seeing how we respond in a way that is supportive for other planetarians, so that we can continue to do our job and make the universe so exciting, and bringing it down to earth for our audiences, and working with everyone who's producing all the stuff that we need to do that, the technology, the shows, the hardware, the software, all of it together. And building a community and network that is truly supportive of one another. And that's a beautiful thing. It's already there. We're not in competition with each other. So that's something I want to make sure that we preserve and protect.
Yeah, and let me sentence. The more that I've worked alongside IPS, the more that I realized that all these really interesting, different moving parts. There's some pieces of it that I didn't even realize were actually a thing that is just so fascinating. Like the data to dome group that you guys have. I think that's like one of the coolest things you could possibly do with astronomical data, is throw it up in a planetarium dome. And just see what happens. And there was this story in the news recently, wasn't there, of people discovering a new structure in some I don't remember quite what it is. Do you have it in your memory?
Not off of that, but like I remember that there was a story of like being able to visualize that data in an immersive way was helpful. And yeah, like that's something I think is a power of the planetarium that we can continue to build on. In the same way that I think like sonification of data is really, really helpful. Like we change our data from something visual to sound. You might hear something that you can't see. But I've also seen things as well. Like for instance, I'm a birder. I love birds. I have like every president's letter includes an unsolicited bird fact now. So people just have to deal with it. But one of the things that's really cool about birds is one, there was an experiment done with baby birds in planetariums that showed when they first navigate for their migration, they use the night sky. Like they figure out where the North Star is and then they fly in the opposite direction. It's really cool. But one of the other tools birds use is they can sense the magnetic field of the Earth and how like concentrated it is, but they lose that ability near the equator. And because of the geometry of how it looks in the sky, it's not actually helpful anymore. It's more parallel versus, you know, at an angle to the ground. And this was something that like I've worked with folks who are ornithologists and they're like, yeah, like I understand that like on a very intellectual level, but to actually see it on the dome when they saw it, like it was like, oh, I see that now. Like, you know, like it's that power of being able to see something in that different perspective that I think is really great about the planetarium. And that's always something that I like to do at my dome. I'm really lucky because I work on a university campus. I get to see people from all these different disciplines and invite them in and be like, what do you do? Let's see what we can put on the dome. And we get to play around. Like it's a sandbox. And that's something that I think is really exciting about where we are. And I like that playfulness that we get to have in our work. And that's something I want to nurture in our field.
So, you know, you said that all of the technology that we have is really changing quite rapidly. I mean, it's true with everything in the world is changing much faster than we ever thought it could possibly change. But the technology in planetariums is moving, you know, away from the star balls that I'm sitting in front of and toward more digital projectors. What are the, like, you know, what's the difference between those two? What's the drawbacks of one versus the other?
So, I mean, there's pros and cons of both. And I think one of the, like, to the credit of the star ball, there are many people who still have star balls because they are still a wonderful, amazing, beautiful technology. My first planetariums, like up until the one I currently use, were optomechanical systems with the star balls. Yes, beautiful, beautiful. Yay. I think I have that one. It's a little model that I got. But the advantage of those is because you are using light through tiny holes, is that the star field that you get is a lot crisper. Like the stars really do look like point sources, whereas with a digital system, you are dealing with pixels. And so you do get some level of spreading in order to actually see the stars. Now, I think over time, those digital systems have gotten really good and it's very, very close, but there is still something that's just like about the star field of a star ball, and really, really powerful. So I think we see a lot of hybrid systems where people can have both because of that. And there are many things that you can do with that, but you are limited with an Earth-based perspective with the starball systems. Like you can't really fly off. You can kind of recreate, like you can recreate different feelings or different planets through different projections of landscapes or something like that, or the baby food jar projectors of before that are still really fun. That create special effects. But a digital system is a bit more flexible when it comes to what kind of data you can do, what kind of places you can fly to, being able to have data in 3 dimensions and being able to bring in 3D models and being able to bring in 360 photographs. So the spherical cameras out there, the 360 cameras, those images you can just pop right into a digital dome very easily for most systems. And it creates a much more flexible environment as a result, which can be a little overwhelming sometimes because there's just so much that you can do. But that's also what makes it really exciting, is that there's so much you can do. And then, like, where I think we're really seeing the next big shift is we've had these digital projectors. Now we're seeing LED domes that are more screen based. And so that's going to be an interesting shift here that we're kind of seeing start to happen in real time.
That's interesting. What would make that, you know, particularly unique over the, like, what could you see better if you had an LED screen?
I think with the LED screens you can get something a lot brighter. Like if you have a big dome full of LEDs, you have the same brightness level at every single point because you have an LED right there, versus a projector. To get similar levels of brightness, the bigger your space, the more projectors you need, the more you need it to map on top of each other. And so I think that's a big difference.
Yeah, okay. Yeah, I mean, all of these changing technologies are really interesting. And so you think that the direction that the field is really moving in is toward the more LED projector, or not projections, LED kind of walls of images up on the screen. So what about for you then? What's the trajectory you see yourself moving in as you move forward, you know, in your career? You said you've been working at this job for the last 11 years. You're the IPS president. You know, what is next for Dr. Shannon Schmoll?
Well, at the moment, we have someone who's been working at our planetarium for 20 years, over 20 years, and he is retiring soon. So we are working on bringing in someone new. So he'll be the first new full-time person since I started. So I think that is going to be a really exciting time, just to see what kind of new ideas are going to be coming in with someone. So I'm excited to explore that. Where I go next, I don't know. I currently I'm quite happy where I am. I think because I get to play around so much with others, I get to play with my friends at work in my universe sandbox. So I think that is really exciting. More broadly speaking, I have certainly ideas and projects I'd love to see come to fruition. We're also, I think, navigating some changes happening around us, and so I'm just trying to also make sure that we're all set up for the planetarium to continue to go on. So at the moment, I'm like I wonder where we're going. I certainly have ideas, but I'm excited for the possibilities and possible collaborations. That's what I'm always looking for. Is I like working with other people and collaborating and sharing ideas, and that's where the best things come, right? And so, yeah.
So I'm going to roll it back a little bit to when you first started talking about your PhD work. You mentioned that you talked about bringing or embedding visits to the planetarium into the curricula of school curricula. So I've read a few different articles that talk about, or that attempt to use the planetarium as a tool to kind of understand people's perceptions of themselves in like a cosmic context. And I'm just wondering if you've seen anything like that you think is really interesting that you might want to talk about or share, or maybe even just like your experience, not necessarily research, but you know, things that you've noticed and the people that you've spoken with, even like within yourself, because it is such a like beautiful immersive experience of being here and watching the night sky in a kind of almost like a protected way. It's a very unique place to be, I think.
I think what I have done in research before has been more around I worked with upper elementary kids on a curriculum that was the path of the sun and moon phases and using the planetarium to help. And so I have seen that as well as other research around just being able to see that motion of the sun sort of sped up is a really useful thing to actually understand, like, why do we have seasons? How does the sun's path change? Even realizing in the first place that the sun's path changes. I think that's something that I also continue to see as I do shows. I now do like a fully live show with students. It's the seasons, and we make predictions on where we think the sun will rise and set. We watch how it moves across the sky and we follow it, and we measure things like how high up the sun is, how long does it take for the sun to go. And that's feels very like down to earth and not like our sense in like the grand scheme of the cosmos. But I think it's one of the first ways that we start to get that sense is a lot of people, I think, like grown-ups, the parents that come in, it's like, oh, the sun doesn't go through zenith every day. It doesn't go directly overhead. And being able to see that and like see that click, I see it like almost every time. It's like, oh, okay. And then it gives you that sense of place. But I also will do things like, let's go out to the observable universe. We're going to fly all the way away from Earth. We're going to see how much of the galaxy we actually see. And then this is, how many stars there are in our galaxy and how many galaxies there are. And I always like to ask that, who feels really tiny now and insignificant, and everyone's like, oh, and they have like that nervous laughter. So like it does have that power to like make you feel that. But one thing that I always like to do and bring it back to is we figured that out. Like we as humans, we had the earth, we had the land that was around us, and then we traveled out farther. And then we started pointing telescopes and seeing how far away planets were. And then we started figuring out galaxies. And then we started figuring out all of this stuff. And even 100 years ago, we thought the entire universe was the Milky Way. That was 100 years ago. And now we have this much bigger thing. So we figured that out without ever being able to jump off of our planet. And we did that because we worked together and we built the technology to do that. And I think that is a good reminder that we are significant. We're not insignificant in this, is that as even if we might be physically small and don't live very long compared to the universe, in that time and in this space, we figured out so much. And it's because we work together. And so humans are amazing for that reason. And I hope that hits home and people don't go home like, oh, but like, okay, yeah, that's pretty cool.
No, and I think that's a beautiful place to end our little segment off on. I think it's really easy to think that we're very insignificant, like you were saying, but the mere fact that we can sit here and think about that.
And
pretty
you
cool.
and I can have a conversation across 13 time zones.
Yeah, indeed we can. Indeed we can. So I am going to thank you very much, Shannon, for talking with me a little bit. And I'm looking forward to talking to you more offline. But I'm going to pass it back to Cosmo, who can lead us into the next hour.
Thank you, Kelly. It was a wonderful talk, I must say, very interesting and very inspirational as well. Okay, so it's time to move, as Kelly just mentioned this, to the next module, where we're going to have some talks about, about from Romania. Okay, from Romania we have another very interesting talk from Dr. Petronia Moraru. We're going to have a talk from Kosovo as well. Then we're going to have participation from the Office of Astronomy for Development, the African Planetarium Association, and the name of the segment, as you may consider, is Diversity, Equity, and Inclusion in Astronomy. For all of you, thank you very much. And as we say in astronomy, clear skies.
Camilo, the floor is yours.
Hello, now you hear me? Do you hear me?
Yes, we hear you.
Okay, thank you. I am so excited to be with you this evening because for me it's an opportunity to share my experience and my thought about astronomy. I am Petronia Gabriela Moraro and I am a physics teacher with a deep interest in astronomy. Today I want to share some of my ideas on how astronomy can become a powerful tool in education, even when schools do not have access to planetariums, because this is the topics for these meetings, the majority of the topics for these meetings. So for me, the interest in astronomy, it's something very old because I was with my grandfather when he showed me the sky, and it was interesting for me to see that the sky is not only something like a picture, it's something beyond this sky that could be interested in, could be understood and could be studied. It was my chance to have such a grandfather, and for me it was a great pleasure to be with him. Summer nights, the bright unpolluted sky were my classroom from that time with my grandfather. One mentioned that I felt compelled to make it that our curriculum does not include the study of astronomy in an organized and mandatory way. That is why I will talk about what an introduction to the study of astronomy should be, and especially why and how to offer something from the experience gained in activities with students in a non-formal system. In my opinion, astronomy is not just the science of stars and galaxies. It is also about a perspective. It teaches us that we are part of something vast and interconnected. For students, the sense of wonder is a spark that can lead to a lifelong curiosity. We can pick their interest with small references within the courses we teach. For example, optics lessons. In my case, especially when we discuss optical instruments, are an opportunity to discuss their use in astronomy since from their beginning. Astronomy also offers us a natural way to apply a STEM approach, integrating science, technology, engineering, art, and mathematics like STEM it is. A lesson about the moon, for example, can involve mathematics in calculating its phases. Art is illustrating them, and technology is using application or telescopes for observation. This interdisciplinary nature makes astronomy an ideal subject for engaging some students. I use, for example, Eratosthenes' experiment to demonstrate that sometimes simple activities lead to remarkable results, but also to make a transition to astronomy from what it within our reach to understand. Also, astronomy is also cultural. It can act as a trigger point between history and literature, helping us to conclude historical narratives with creative expression. You know, a lot of literary creations that are during the history that are approaching the life to astronomy. I am convinced that many other colleagues, including those who teach literature or history, can make such references that will arouse the interest of students. For example, when we study how ancient civilization read the sky, we can associate it with myths, poetry, or stories inspired by constellation. Students can discover not only the fact, but also how the human imagination has always been connected to the stars. This helps us building bridges between the past and the present, showing how curiosity led to today's scientific achievements. It is something interesting for them to connect all these facts and all these thoughts. Such an approach is also important for inclusion by connecting astronomy to literature, storytelling, and creative expression. We open doors for all students, including girls. It's one of the problems that we have these days, who have historically been excluded from sciences, or they are considered that sciences are not for them. Astronomy become a shared human story where every voice counts and where curiosity, not context, it is the starting point. The starting point is important in every study, but in my opinion, for astronomy that is not included in the curricula, it's more important than for the others. Of course, not every school has a planetarium or easy access to an astronomical observation, but we can still bring the universe into our classes in different ways. There are many observatories who facilitates for us live observation, like Sluch Observatory, a virtual telescope project from Italy, Las Cumbres Observatory that we use for such broadcast live images or for studying the sky for free. These instruments make the sky accessible even for school without local resources that are far away from planetariums or observatory. But for those who have the opportunity, they can organize after-school events where students can participate in live sky watching sessions in a fun way, and are encouraged to discuss and use their imagination. For us, it's more important because we cannot organize other way the activities than after the school. In the classroom, we can design activities that combine research, creativity, and technology. I will present some few of my activities, some ideas about activity that we can easily organize with minimum resources. We can start with simple activities that are attractive for students. For example, a few years ago, we organized solar system model for the first time in our school. We asked the student to establish a route in the school that represented the total length of the solar system to be for a scale. The students then established the corresponding distance between the various planets of the solar system, including the Moon and Pluto. Even Pluto is not considered as a planet for the moment, or is discussion about Pluto if it is a planet or no. Each participant occupied a position on the route corresponding to the relative distance to its astronomical neighbors. It was really fun to establish the position of the sun. I asked the students to decide which will be the sun, where will be the position of the sun. Everyone has only one proposal, the director's office. It was very interesting for me to see that in that way students were very open-minded for their activity. When I asked them to communicate with their neighbors, it was even more fun, considering that they were distributed over the 3 floors of the school. Anyway, it was a good start for the group to participating students to discuss astronomy and understanding the distances and the scale of the universe, starting from the solar system. Another activity that we organize with our students is a constellation detective, where students research the history and mythology of a constellation, then present this as a detective story, how ancient people solved the puzzle of the sky. If the number of participant students is enough, each can become an ambassador of a constellation, and at the end, the puzzle of constellation or of the northern hemisphere, in our case, was recreated. We intend to develop a new activity where with the same steps, we intend to recreate the constellation of the southern hemisphere. So we will develop their knowledge and their understanding that the position on our Earth planet, it's important for their observation. Other activity that we develop is do-it-yourself star projector, where we encourage students to build simple cardboard projector with flashlights to recreate image of constellation, integrating in one way the engineering with the storytelling. Their creativity was stimulated to solve some simple problems, like how will you use this projector during the day to see the images? How would you use it at night? And if it is differences between the two observations. Some students might find it helpful to to make the presentation more personal, because we ask them to create an artistic representation of the projected constellations, starting from its name. We also ask them to imagine another name and another shape of the constellation. We intend for them to understand that constellations are, in a way, just an imaginary way to represent connection between stars. We decided after this activity, and we intend in December to create a dome in our school, a bigger dome for projecting the constellation, and we intend to involve as many students as possible for this common activity. Other activity that we developed is exploring the sky with the apps. It is a two-way activity, because we firstly introduce these apps like Stellarium or Google Sky Map, and after that, after a short presentation in the class, and let them the time for understanding the application, how to use it, we organized a common activity during the evening, and we organized the activity in two ways. For those who could participate, they were with us together in the park of the city, but also we make a connection with the others, online connection, so we can discuss and we can present each other what we saw and what it is important for us. If the school have access to the planetarium, the impact for students is bigger than for these activities. If we can organize a visit to a planetarium, this visit could be transformed into an important experience for students who are immersed under a dome where the universe come alive. What makes this event even more powerful is that students, when they return to their classroom, share their experience with peers, presenting what they saw, photos, short videos, or even their own reflection. They spread their enthusiasm, and this ripple effect helps raise interest in astronomy across the whole school community. Through these activities and experience, students learn to investigate, to imagine, and to create. The classroom becomes a mini planetarium, and every student, regardless of gender or background, can see themselves as an explorer of the universe. Planetarium, of course, remain essential cultural and scientific spaces, but if we don't have the access directly, we can recreate it in our schools. There are places of immersion and inspiration, but even without them, astronomy gives us a way to unite science, history, and the imagination, and to inspire the next generation of dreamers, thinkers, and innovators. This is our contribution for the study of astronomy. We are amateurs, and we are those who love astronomy and want to transfer to our students our love for this interesting and wonderful domain of study. Thank you for the audience.
Thank you, Petronia. It was an amazing experience that you are talking to us. What was the most challenge that did you find it when you did your activities? What was the most difficult thing now?
The most difficult is to overcome the barriers of cultural experience of the students. It is difficult for them to understand that what they see must be interpreted in another way. They must transfer their small knowledge that they have to another domain, and they must make a connection between different domains of study. We started always from the history. We starting from the old observatory, so-called observatory from Babylon and Mesopotamia and so on. And step by step, we come to our days, but it is difficult for them to understand that in the last 200 years, the development of the knowledge in this domain is so amazing. And it is a turnaround for their knowledge from the beginning to the end.
Okay. Thank you so much, Petronia. So now we're going to go with our next speaker. This is Suhel Ameti. He's from the Astronomy Club of Kosovo and Pristina Observatory and Planetarium at Kosovo. So welcome to our space and go ahead with your experience.
Thank you so much. You can all hear me, right?
Yes, of course.
Hello, everyone. Good evening from Kosovo here at the observatory. We're having some stargazing nights for the 100 Hours of Astronomy. It's an honor to be part of this international event, and Kosovo is participating for the first time, actually. My name is Suel. I'm the NOC, National Outreach Coordinator for Kosovo, part of the Office for Astronomy Outreach. And our observatory here, was built in the 70s, but actually it was never working again since I'm 40 years, I think. And in 2022, we reopened it with the support of United Nations, the mayor, the Ministry of Education. So for 3 years, we have hosted more than 30,000 visitors, actually. And it's so glad to be part of this celebration to tell that indeed astronomy unites us all. And we are all made of star stuff, no matter who we are, where we come from. Since 2022, we've hosted different outreach activities. And for the 100 Hours of Astronomy, we're having some stargazing activities, workshops, the guided tours, and right now our planetarium is under construction. So it's a good step that Kosovo now is going to have another planetarium. Our astronomy club became the first one when it opened in 2014, being the first astronomy club. And then later we had other organizations who became part of this event. I just want to tell that no matter where you are, there's a saying that says that the sky actually belongs to no one and to everyone. So meaning that even though when we look through a telescope, maybe we feel small, but actually we are big because we are part of this universe. And astronomy has the power to unite people. And here at our organization, we do different activities that promote trust, interethnic trust, and collaboration in this part of the world. Kosovo is located in Europe. For those who doesn't know, it has the youngest population in Europe. For young people being under 30. And it has become a driving force behind so many activities. And I think the most active club actually in the region. Right here is our observatory. We have a Bresser telescope behind my back. This is where we organize most of our activities here. And in the ground, we did some beautiful mosaic. We can tell that astronomy also is art and culture, so we want to promote this field also. And as a national outreach coordinator, we are part of different activities that the Office for Astronomy Outreach organizes. For example, like Women in Astronomy, Women and Girls in Astronomy, which we also was part of that. And I look forward to also participating for the next CAP conference, Communicating Astronomy with the Public. We hope that this event will also happen in Kosovo in the near future. It's such an honor to be part of this event, and I encourage you all to look up in the night sky because we say that sky is not the limit. There's so much beyond the sky. And here at the Astronomy Club in Kosovo, we try to bring this beautiful meaning of astronomy to all communities and underrepresented communities actually in Kosovo, minorities. So we want to promote astronomy for equity and inclusion. Our organization is part of different astronomical institutions, including the Astronomers Without Borders, Stars Shine for Everyone. And we believe that astronomy has the power to unite us all. I don't know if you have any questions. I would love to answer them to you. Other than that, I wish you all successful events, all astronomers and all astronomy clubs, planetariums around the world for the 100 Hours of Astronomy. It's such great that Kosovo is participating for the first time in this global event. And even it tells that even a small country like Kosovo can have a global impact, become part of such event. And I thank the Office for Astronomy Outreach and the International Astronomical Union for giving us this opportunity to tell what we're doing in this part of the world. And this is why I love astronomy, because we can all connect with each other, and no matter where we are from the world. Me, myself, I don't have an astronomy degree, but I've always loved astronomy, looking at the night sky, and I want to share my passion with people all around me. Unfortunately, in Kosovo, we don't have any astronomy institution or like school or university which we can study. but we are starting somewhere, and we're gonna form the next Astronomy Academy in Kosovo. This is where it all started. As we say, like, great things have small beginnings, just like when the universe started from a big bang. And it's same for our organization and for astronomy in this part of the world. Right now we are in actually we already entered the fall season, and it's getting cold. And people are waiting on the line here at the observatory to observe the moon. Fortunately, we have good weather here, so we're looking forward to our 100 Hours of Astronomy event, and we have a high interest of people to participate in our event.
Thank you, Suhail. It's your first time here with us.
It's my first time, and also for Kosovo actually to participate in this event, international event. And I feel very honored to be part of this event, to talk to you and to all people around the world, or aliens if they are somewhere watching us.
Thank you so much. Now we're going to give the word for Kelly Blumenthal. And after that, we're going to introduce. Okay, no. Yeah.
Konnichiwa. My name is Kelly Blumenthal. I am the director of the International Astronomical Union Office for Astronomy Outreach at the National Astronomical Observatory of Japan in Tokyo. Now, while you all are learning about the moon, we are here celebrating our big annual event, 100 Hours of Astronomy. And as one of our many initiatives to bring the world together through astronomy, 100 Hours is a marathon of events held all over the world and hosted by people just like you. This year, we are celebrating the 100th birthday of the planetarium with the International Planetarium Society. And as one of our main events, we are hosting a 24-hour live stream celebrating the planetarium and the many ways that people all over the world celebrate and engage with astronomy. Now, we are here streaming live from the oldest functioning planetarium in all of Japan, the Akashi Planetarium. And we'll be here for a full 24 hours, so come tune in and hear how people talk about the sky that unites us all. Now, this moon isn't quite the same moon that you're looking at tonight, but in a couple of days, when the moon is full, people across Japan will be celebrating Tsukimi, the lunar festival, and we'll be eating dango and mochi and kombucha and many other delicious foods. And of course, we'll be looking at the moon. So we invite you to join us to celebrate Tsukimi and 100 Hours of Astronomy. And if you want to learn more about 100 Hours and the Office for Astronomy Outreach, come find us online and on social media. Matane!
Thank you, Kelly, for this amazing video that shows us the next supermoon activity that we are going to have. Now, I would like to give the opportunity to talk to Ramasamy Venugopal. So, welcome. Rami.
Hi, how are you? Thank you, everyone. Great to be here. My name is Ram, and I work for the IAU Office of Astronomy for Development based in Cape Town, South Africa. So here we go. So the IAU OAD is all about using astronomy to create a better society, right? And all of us know that, we need a better world and a better society because our world is indeed at peril. So astronomers love looking at the fireballs in the sky. They love studying them, learning about their life and death and influence and so on. But we also have fires on Earth, literal and metaphorical. But the question is, why should we care? Is this our responsibility? Should the astronomy community concern itself in dealing with the problems of society? Because we have our own issues to deal with, we have our own things to do, and we frankly don't have enough resources to do astronomy as it is. Plus, astronomy community is not best place. Maybe we are not the experts in solving the problems of our world. But there's another question. Do we even have a choice? So first of all, there are many, let's call them bad actors around the world who in fact misuse and misrepresent science for personal gain. And without scientists in the scientific community standing up and letting their voice be heard, using their authority, we probably will contribute to a worse situation. On the positive side, astronomy is a very inspirational topic. It's deeply connected to our heritage. It's very much part of our culture. And there are a lot of strengths in astronomy that can be leveraged for positive benefit. And the third one, of course, is the community. So all of you watching, everybody will be watching the YouTube stream later. Astronomy, the community of astronomy has had a major impact on society. It's just a few thousand people right now, and it was even smaller before. But this community has had a major influence on society, and there's no reason that we shouldn't use this influence to create a better world. So what do? The OED? We are a coordinating center. We don't run a lot of projects ourselves. So our role is to enable and support you and people across the world to engage in astronomy to create a better world, to promote sustainable development. And we do this by creating resources. So we look at research, we study the literature, we create new material, we develop case studies on what's worked and what hasn't worked, we do impact evaluation, and we make all of these resources available to anyone who wants to use astronomy for development. And we have training courses available both in person and online, and community. I mentioned this already, but we recently launched a online community on Discord. So you can find the link on our website. And everyone is welcome to join this community. If you're passionate about astronomy, if you're passionate about creating a better society using science, please join us. And we also support implementation of astronomy for development projects through our grants program. We help you design and develop programs and help you implement them. So we have three main focus areas. One is astronomy tourism. So this leverages the attraction that people across the world, the fascination that people have for astronomy and the night sky, and we use it to benefit communities, particularly in rural areas where there's amazing night skies, economically, socially, and so on. So we have a separate website for astrotourism. You can check that out. And the second closely related focus area is using astronomy for mental health. My colleague Dominic gave a entire presentation on this a few hours ago. You can find that on the YouTube stream. So this leverages the inspiring potential of astronomy to improve people's mental health and well-being. And you can look at the website for that. And finally is about using skills. It's both the development of skills through the lens of astronomy, and then application of said skills to tackle big problems in society. In fact, we currently have an open call under this flagship. So our Hack for Dev, Hackathons for Development program, it drives innovation, it accelerates innovation and skills development by supporting the organization of hackathons all over the world. So if you're interested in data science, machine learning, innovation, creating a better world, please look at our open call. This will support people, this will support teams who want to organize hackathons in their own institutions and communities. And the deadline is pretty soon, so it's end of October. So we have examples from all over the world. I don't want to get into too much detail, but we have projects that train students to earn an income while they're studying through the astrotourism initiative. We have projects that inspired young children in displaced communities through astronomy and space. We have projects also that used a combination of mentorship and astronomy workshops in rural areas to reduce the rate of school dropouts among girls, and of course the hackathon program that I mentioned. So let me stop here. This is our website and this is my contact information. Please contact us or visit our website for more information.
Thank you, Ram. It's a pleasure to see you again with this amazing project. So now we're going to give the opportunity to talk to Susina Desu, or that is related with the African Planetarium Association. Maybe, yeah. Oh, okay.
From a single point of infinite density, the universe was born. In a fraction of a second, space, time, matter, and energy burst into existence. Galaxies swirled in a shape, stars ignited, and planets formed. Among billions of galaxies, one spiral arm of Milky Way cradles our home Earth. From the vast cosmos of the land of Africa, we remain forever connected to the story of the universe. Our blue planet shines like a jewel in a vast darkness of space. It's alive, oceans moving, forests breathing, life thriving in harmony. Humans' journey begins here, on a cradle of Africa, where the skies have guided culture, science, and imagination of thousands of years. The stars continue to inspire discovery, uniting tradition with the future of exploration. Since the dawn of time, humanity has reached the skies, from the pyramids of Egypt to the Stone Age, from Mayan temples to Asian star charts. Africa, the cradle of humanity, carries this global heritage. In Ethiopia, ancient calendars and cultural wisdom meets modern discovery. Heritage and science walk together, guiding new generations under the same stars that inspired our ancientors. The story of astronomy, astrophysics, and physics is shaped by brilliant minds across the world. From Copernicus and Galileo, who reimagined our place in the cosmos, to Newton, who revealed the laws of motion and gravity, to Albert Einstein, who unfolded the fabric of space and time, to Marie Curie, whose pioneering work in radioactivity transformed science, to Carl Sagan, Stephen Hawking, Pierre Rubin, who expanded our understanding of the universe and galaxy. Their fingerprints shape the way we understand the universe. Today, we continue this journey, blending heritage with discovery, science with society, and inspiring new generation under one sky. Planetariums are windows to the cosmos, bringing the universe to every mind and heart. Across the world, they inspire imagination, curiosity, and discovery. In Africa and Ethiopia, planetariums unite heritage with science, guiding young explorers to dream beyond the stars. This year, we proudly celebrate the 100 Hours of Astronomy and the 100 years of anniversary of planetariums. Milestones that honor generation of science, outreach, and show how human imagination can connect us to the universe, bridging past, present, and the future under one sky. I'm Susina Desu, Vice Chair of the African Planetarium Association, and researcher at the Ethiopian Space Science and Geospatial Institute. My mission is to connect science with society, ignite curiosity, and inspire the next generation of explorers. I give thanks to God, my mother at Maswork Umangasha, my mentors, Dr. Gamechu, Professor Mirjana Povik, Professor Amara, Professor Sally, Chairman Leon, and Mr. Abdesa Ilma, whose guidance strengthens science and outreach across Africa. From Ethiopia to Africa, from Africa to Earth, from Earth to the universe, we are one human family under one sky, one world, one sky, one future. And as we explore, learn, and imagine, we uncover the most unknown.
It looks like our host must have lost his internet connection, unfortunately. Well then, let's see who's next on the docket. Yes, Amelia. Amelia used to be the chair of the working group at the International Astronomical Union dedicated to diversity, equity, and inclusion in astronomy. And she recorded a special video for us to talk a little bit about the work that she did and the importance of that work.
Hello, good morning, everyone. My name is Amelia Ortiz-Gil, and I am an astronomer working at the Astronomical Observatory of the University of Valencia in Spain. First of all, I want to thank Kelly because she has invited me to share with you my experience on working about diversity, equity, and inclusion in astronomy communication. So I started to work on DEI just by chance. At our observatory, we have a program of school visits, as it is in many other observatories around the world. And then one day we received a request from a school for kids with disabilities that they wanted to come and visit us. So me, as you all, are always very passionate about communicating astronomy to everyone, and we couldn't say no to them. So we accepted the challenge, and together with their teachers, we developed an adaptation of our workshops for the regular schools, and especially for these kids. The experience was a real success, and we realized that we had to do something to reach a wider public. That meant including these people with disabilities in our regular activities, not just in this exceptional occasion. That's how we started to develop some resources and materials for people with disabilities, at first with different disabilities, but then after a while we started to focus on 3D tactile materials for the blind and visually impaired. So for the International Year of Astronomy, we developed a planetarium show for the blind, The Sky in Your Hands, and it had a hemisphere with constellations in relief engraved on it, and this was done following the example of previous experiences in Argentina by Sebastián Musso. And we also developed a tactile model of the moon. It was not a topographical representation of the moon, but it was a representation in relief of what we can see when we look to the moon. So the craters were quite exaggerated, and we erased some of the, or smoothed out some of the details of the surface just to make it more understandable to the blind users. Because if the model had too many details, then it would be quite confusing for them. And after that, we started to develop another models of different of the terrestrial planets. We created Mars, and then Venus, Mercury, and finally the Earth. And in the last couple of years, we have started to develop other kind of models. We have now a model of Laniakea, which is the supercluster where we live in, or we have also modeled baryonic acoustic oscillation, and a model of an AGN, or the Milky Way as it is seen by Gaia satellite. So we have all these models we use not only for blind users, but also for regular kids and general public, because it's for everyone. It's really inspiring to be able to touch a piece of an astronomical object, or a piece of the universe in the case of Laniakea, or the Coma cluster, which we have also modeled. So therefore, I will end up by encouraging you all to include diversity, equity, and inclusion in your workshops, to try to be as inclusive and as possible. You can do that following the universal design for learning principles, for example. And I will leave you here with with 3 links that I think can be useful for you. And this one is the Attach of the Universe, which is our project where we have where we present all the models that we have developed along these years, and you can download them for free. We have every model comes with a little explanation about what it signifies, what it means, and the physics behind it. And we have also developed some activities, educational activities related to these models that are currently under review on AstroEdu, the IAU platform for educational resources. And then I want you to know that there is a group, the IAU OAO Inclusion. It's OAO is really committed to inclusion in the astronomy outreach, and here you can find the link to that side of the website of the OAO. And finally, there is a working group which is called IAU CAP Inclusive Astronomy Communication, which gathers people who are keen on sharing or learning about how to make their activities or their outreach more accessible to everyone. So I invite you all, whether you have experience or whether you don't have it, to join us and to participate in this community. And well, this is all from my side. I just want to wish you a very happy 100 hours of astronomy. Bye-bye.
Thank you, Anneli, for that. Now, I would like to invite Anneli, because we are going to talk about diversity, equity, and inclusion in astronomy and Hours of Astronomy. So if you want to present a little bit yourself, I'm going to present myself, and we can discuss this topic. We have 10 minutes to do that, so go ahead.
Hi, I'm Anaeli. I live in Mexico, and my current project is called Astronomía sin Barreras, Astronomy Without Barriers. And the main objective of this project is to break the barriers that some people faces in order to access astronomy. We have currently two projects that are focused. One is focused on children and teenagers living under social care institutions in my city, that is in Puebla, Mexico. And the other one is focused on the deaf community in Puebla, particularly for the in-person activities, but we have online resources also, or we plan to have more online resources that can be available so the deaf community in Mexico have access to those information. And the plan is to provide information related to astronomy in Mexican Sign Language. And the first part of the project was basically in-person workshops related to astronomy, and we cover a list of around 120 concepts related to astronomy, and we found that only 8 of those concepts already have a sign that is used commonly in the deaf community here in Mexico. So we found that more than 100 of the concepts are totally new to the community because it's new. It's like a vicious circle because they don't have access to this information because it's not in their language, that is Mexican Sign Language. And even though when they are interested in astronomy, but it's also not something that is not of their common life, or they find the usefulness of having the signs. So when they access this information, they don't have these words. Basically, it's like, imagine, I think this also happened, for example, in a previous work with a native language here in Mexico that is called centennial. So we found that mostly all of the mainly the newest astronomical concepts or the more modern concepts, for example, Big Bang, doesn't have a translation in this language. So it's something that these communities have in common. The language is not there, and is the first thing you have to access information. So we are trying to work in this project, going towards that. And I think that is going to be interesting, but also is very necessary. And we hope that we can give like a pathway for other astronomical associations or planetariums or universities or research institutions that they can involve this community, the deaf community in particular. That, especially because the last week of September, for example, is the International Week of the Deaf People, and we provide some of these role models that are related to astronomy that most of the people don't know that they are deaf people or were deaf people. For example, in Mexico, I live in Mexico, and we have like a lot of places that are called Luis Enrique Erro, and most of the people don't know that Luis Enrique Erro was a deaf people, was part of the deaf community. So it's like, it's like also part that we are trying to do, for example, in women in STEM, no? We are trying to give visibility to women that work in STEM and the barriers that we face as women, but we also have to find these other role models that are also facing barriers and exclusion and forgiveness, and they are forgotten and lost in this history. For example, even though when we have places that are named in honor to this man, we don't know this. In fact, there is no like information of how he became deaf, when, and something like that. We only know that he was there because in Tonancinta, where is the observatory of Tonancinta, there is a solar telescope and has a little plaque inscribed that says that this telescope was bought by Luis Enrique Erro with money that was given to him from the president at the time. Avila Camacho, if I remember correctly, to go and have an operation for his hearing. And it's the only like evidence that we have that he was a deaf person. So
Okay, I
it's
think, yeah, I
yeah.
think we need to talk, we need to discuss, because here in Colombia, I'm Camilo Delgado Correal, I'm the representative of the Outreach Office here in Colombia, and we develop a material that we use the path of the solar eclipses.
Mhm.
So the people with disability, visual disabilities, just can touch how is the basic knowledge of eclipses by just touching, because they are more strong in this sense. And after that, we begin to use it by people that can see. But in this case, we are talking about how to do astronomy without seeing, no? So
Yeah.
it's something. So we put some cover on their eyes, and they become to do the same activity. So for them, it was amazing, because it's not usually that you can use the other sense to feel the astronomical concepts. So this is something that we are developing. It's not just for people with the disability. It's also
Yeah, yeah.
that for general public, that they appreciate all the privilege that they have. They can see everything. So this is something that we are doing this way. In the okay, we have the other thing is the equity also. No, we are increasing the numbers. We like to have this gender balance. We're working here in Colombia in the amateur and the professional community. This is very strong.
Yeah,
So in all of our activities, we're looking for that we have this gender balance. What is the case in Mexico, for example, with this situation?
Yeah, well, I have experience knowing some, for example, in the professional field, there is still an imbalance. For example, there are no opportunities for mothers that are researchers in, for example, having a place to take their kids and don't have these nurseries for their children and make their life easier in a way, so they can be more productive also in the research field, but also in the amateur communities. There is also, we're trying to find more balance also, because if you meet some of the astronomical societies that are amateur, there is also more men and young children, male. So we are trying that too.
And the other thing in our culture, for example, is how to involve the ancient cultures, not the indigenous cultures that we have there. Do you try some activities in this way?
We also are interested in astrotourism, because, well, we want to use astronomy not only to provide information about astronomy, but also the phrase of the project, Astronomy Without Barriers, is also experienced in a shared universe, is because we know that astronomy is related to almost everything that the humankind has done since ancient times, and we have the eyes and we start looking at the sky. We found, for example, the movements of the sun that help us measure time, and the moon and the phases, and how it helped, for example, ancient communities to measure time, but also understand when is the better time to crops and certain animals and certain activities that you can do. No? Maybe with the new technologies and the commodities that we have currently on our time, we have the watches, we have the GPS, and we don't really need, or they don't use the sun to measure our time or calendars. We have lost this connection. I think it's important to relate again to that, to the darkness. That also is part of the project or the idea of the project behind that is protect the dark sky, because after all, we evolved in a rhythm in light and dark, and we are now we don't have now this dark most of the
Yes,
time.
yes,
And
true.
it's
The
not
light
only
pollution.
affecting us, yes,
Yeah,
it's affecting to
it's
all
true.
the living things that share this planet, in this case the planet, but also the universe, because it's the only kind of life that we know in the universe, basically. So we have to remember that everything that we do is not only affecting us, but it's also affecting the other creatures that are sharing our space and time. I think Camilo is lost.
You might be right about that. Well, thank you so much. We are going to move on to the next stream link. But thank you, Anneli, and thank you, Camilo, wherever you've gone off to, for this really interesting conversation. I hope that in the future, thank you.
Thank you,
we can
Gary,
have,
for staying with us.
yeah, great.
Have a nice day.
All right, thank you so much. All right, we will see all of y'all on the next Zoom or stream link that's in the chat now for this YouTube channel. So we'll see you in just a little bit.